Which one? Speakers are sharing. Audio. Audio. The scope of research in nanomaterials extends far. Good morning and welcome. Good morning and welcome to all esteemed faculty, research and students who have joined us today for this national webinar on Tiny Wonders, Big Future, Making and Understanding Nanomaterials, an event that promises to focus on the world of nanomaterial synthesis and its vast potential. We have gathered under the banner of the D.S.Govt Degree College for Women to embark on a journey through the realm of the infinitely small yet unimaginably impactful field of nanotechnology. The selection of our resource persons for today's webinar is a testament to our commitment to fostering a rich learning environment and promoting cutting-edge research. We are privileged to have among us distinguished scholars such as Professor N.V.S. Venugopal from Gautam University, Dr. T. Anil Kumar from Krishna University, Dr. T.N.V.K.V. Prasad from Acharya Anjiranga Agriculture University, and Dr. J.N. Kiran from Vignan Foundation for Science, Technology and Research, Guntur. These experts bring a wealth of knowledge and experience in nanomaterials, and their presence today aims to inspire and guide faculty and students as they venture into the field of nanomaterials research. The choice of these resource persons reflects our vision to encourage research activities that do not necessitate overly complex equipment for synthesis. This approach is crucial, especially for government degree colleges in the state of Andhra Pradesh, where resources optimization is key. The methods and insights shared today will shed light on how one can make significant stride in research with minimal resources, thereby democratizing access to nanotechnology research and innovation. The scope of research in nanomaterials extends far beyond the laboratory. Nanomaterials hold the blueprint for the future, with applications ranging from healthcare, where they can aid in targeted drug delivery, to electronics, where they are revolutionizing device building. The ethical and safety considerations in nanomaterials research also open avenues for inquiry into responsible innovation. And let's not overlook the collaborative opportunities that nanotechnology presents, bridging academia, industry, and policymaking. In today's webinar, we will explore the synthesis of nanomaterials with advanced techniques, understand their diverse applications, and discuss the societal impacts they entail. We aim to foster an environment of collaboration, ethical research, and above all, innovations that resonates with the current and future landscape of science and technology. As we proceed, let this webinar ignite a spark of curiosity and a desire to excel in each of you. May it be stepping stone for those new to the field and source of advanced knowledge for the experienced. Let us embrace the tiny wonders that pave the way for a big future. Thank you for being a part of this event today. Together, let's progress towards a future where we can fully utilize the wonders of nanotechnology. Thank you. Thank you.
Good morning and welcome to Tiny Wonders, Big Future, Making and Understanding Nanomaterials. It is my pleasure to extend a warm welcome to each and every one of you joining us today. Today marks a special occasion as we gather together virtually to explore into nanomaterials. This webinar represents an opportunity for us to come together, exchange ideas, and engage and meaningful discussion that have the potential to inspire, educate, and spark new perspectives. Throughout our time together, we will have the privilege of hearing from distinguished speakers, experts in their respective fields, who will share their insights, experiences, and expertise on tiny wonders, big future, making and understanding nanomaterials. I am confident that you will find today's discussion both enriching and thought-provoking. I encourage each of you to participate, ask questions, and contribute to the conversation. Your insights and perspectives are invaluable, and they have the power to enhance our collective understanding of tiny wonders, big future, making and understanding nanomaterials. Before we begin, I would like to express our sincere gratitude to all the speakers, organizers, and participants who have worked behind the scene to make this webinar possible. Once again, welcome to Tiny Wonders, Big Future, Making and Understanding Nanomaterial. Thank you for being here, and let us make the webinar an experience to remember. Now, our principal madam will continue.
Good morning, all. It's my utmost pleasure to welcome you to this webinar focused on the marvels of nanotechnology encapsulated in our theme, Tiny Wonders, Big Future, Making and Understanding Nanomaterials. In a world where innovation is the fundamental principle of progress, nanomaterials stand out as one of the most transformative and promising fields of study. As we search into the domain of infinitesimally small, we unlock vast potential for revolutionizing industries, improving healthcare, and addressing pressing environmental challenges. Nanomaterials, engineered at the nanoscale, possesses extraordinary properties that violate conventional wisdom. From unparalleled strength to remarkable conductivity, their characteristics pass over the norms of the classical theories, paving the way for a new era of possibilities. Our journey today is twofold. To understand the intricate mechanisms behind the creation and manipulation of nanomaterials, and to envision the boundless opportunities they offer for shaping our future. We'll explore the diverse synthesis methods from top-down approaches like lithography to bottom-up techniques such as chemical vapor deposition. Each method represents a stepping stone towards crafting materials with tailored properties, opening doors to applications previously deemed impossible. Moreover, we cannot ignore the ethical and safety considerations inherent in our exploration of the nano world. As we marvel at the wonders of nanotechnology, we must remain vigilant in our commitment to responsible innovation, ensuring that the benefits outweigh the risks and that our advancements are sustainable for generations to come. In the grand disparity of human endeavor, nanotechnology represents a thread of unparalleled potential. As we embark on this journey together, let us embrace curiosity and collaboration. Let us dare to dream big for the world of nanomaterials. Even the tiniest wonders have the power to shape a brighter future. Thank you for joining us on this extraordinary event into the nanocosmos. Together, let us seize the opportunity to make and understand nanomaterials, paving the way for a future limited only by our imagination. Thank you. Thank you all.
Now I am inviting our first speaker, Dr. J. Kiran Garu, who has 20 years of teaching and research experience. I am giving a brief introduction, a brief about Nischal Kiran sir. Sir is a reviewer for journals, so many journals. Some of them are Journal of Advanced Physics A and Journal of Material Science Research Express and Journal of Metals, Journal of Materials Today Proceedings and Journal of Processing and Applications of Ceramics. Sir was also a UGC reviewer for S. Radhakrishnan Postdoctoral Fellowship, 2 projects from 2023, and Dr. D.S.GovT Research Grant for newly recruited faculty members from 2023, the first project, and is also a UGC reviewer for research grant for in-service faculty members in 2023 project. Sir also has guided 6 PhD scholars, and this is a brief about Dr. J. Nischal Kiran sir, and sir will give you nanomaterials from known to unknown. Thank you one and all. Sir, Nischal Kiran sir, good morning sir. Sir, you please continue sir.
Respected Principal Madam, the organizers of today's webinar, teaching fraternity, student friends, a warm good evening, good morning to one and all. This is Dr. J. Nischal Kiran from Vignan's Institution, Vignan's Foundation for Science, Technology and Research, deemed to be University, Guntur. I feel immensely happy to associate myself with the webinar of the theme Tiny Wonders, Big Future, Making and Understanding of Nanomaterials. I appreciate the organizers for the thoughtful and thought-provoking theme. It gives me pleasure to share the knowledge that we have gathered, share the knowledge that we have, and the information that we have gathered, and the research inputs that we are there with, considering the nanomaterials on this eventful day. I now prefer sharing the PPT, which I want to present today, in the interest of all the people who have joined us for this national level webinar. Is the screen visible, ma'am? Hello?
Yes, sir. It is visible.
Oh. Once again, I welcome all the participants for today's webinar. The beauty lies in the eyes of beholders, as is being said by Margaret Wolf, an Irish novelist of 19th century. So is the way the tiny particles, the big wonders are. In the sense, the way we look at them will be the way that we perceive the things are. So it is on that note, I'd like to continue with my presentation, taking you from the known to the unknown of nanomaterials. As I embark on it, my very point is, we as science fraternity, will always look for exploration of what we have in Mother Nature. So, to the very God's creation, we have the nature. All the wonders were there, well within. It is our responsibility to have the blessed understanding of the same, duly exploring them up in the way that they ought to be done, so as to remain knowledgeable of what we are being installed of, and continue the very point of looking at them in the futuristic viewpoint. Okay. Now, as the title reads, Tiny Wonders, Big Future, Making and Understanding of Nanomaterials. I prefer bringing this to your notice, moving ahead from known to unknown, as is being already spelled. Now, these are the contents of my presentation. We'll check for the brief introduction, the history aspects, principles, the classification of these materials, the very synthesis, the making of the nanomaterials, the vital properties which distinguish these materials from the rest of the bulk materials, and their befitting applications and diversity we will try to check out for, and we also try to underline the very future of nanotechnology. So as is being said, the tiny particles, it forms our responsibility to understand the size aspect of the materials. So as we all know, right, a meter, right, it is equal to 3.28 feet, and from meter to millimeter, it is 1,000th of a meter, and micron is the millionth of a meter, and the nanomaterial is 1,000th of a micron, or a billionth of a meter. So these are the very tiny particles. As on date, people are also with the understanding of, right, pico and femto presentations of the dimensions of the particles, but it is as we find very difficult to hold them by those sizes. They are still under exploration. But nanomaterials, by their nano dimensions, right, are very much possible and can be understood and explored further for the detailed applications of the same. Now, coming to the very historical aspect of it, it is to the very famous lecture of Richard Feynman by 1959. It was being told to us there is plenty of room at the bottom. Okay, but as a science fraternity, we may have to understand every aspect of it from the observation, and we got to have that being received from a hypothetical sake, as is the case here. There is a plenty of room at bottom. It is in the beginning is a hypothetical sake. Later, it has to be theoretically understood, experimentally being realized, so that we can come out with a principle or a concept. So when it is being first given an idea, a thought of, right, we are not in a position to see those particles in any way. It is in the year 1981, right, we had the invention of the scanning tunneling microscope, which enabled us to look for the very tiny particles and manipulate them to the very desired presentation of us. So people felt so allured of the very point of we dealing with these particles. Now, as we check out for these nanoparticle systems, right, these nanoparticles are special by some of their attributes. Some of them, which are enlisted here, they'll have high fraction of atoms at or near the surface. All the liquid surfaces behave as they are an elastic film. One more aspect by which these are different from the bulk materials is high vapor pressure over small droplets, which we name it as Kelvin effect, and Ostwald ripening is yet another aspect to be given importance, which says about large particles grow at the expense of the smaller particles. Then later, it's all about the adsorption, where impurities tends to stick to the surfaces. And the other aspect which need to be invariably understood is absorption of ions can leave the nanoparticles electrically charged. So to summarize in one say, these nanoparticles are with special attributes. They are with very good surface to volume ratio, and they'll be with quantum confinement presentation. And now, this nanotechnology is not new to us. Most of the time, as I already mentioned, it is from the mother's nature. We have mimicked many things. So nanoscience, biomimicry, if you look for, so the ways the scientists are attempting to mimic the wonders of nanoscience in nature, we can find from this slide. So sticky feet. The sticky feet of these reptiles, enable them to move upside down, because by the very palms of them we'll have the nano indentations, which because of those nano indentations and due to high surface to volume ratio, they will go stick in to the very surface on which they were there moving. Similarly, we have the strong spider silk. So the spider silk will have the nano indentations, which will make them being so tough with good strength as such. And self-clearing, light-reflecting butterfly wings. So we have these butterfly wings will be there being of different colorations, and those colors will be mostly due to the arrangement of nanopixels over the very surface of the butterflies. Optical nanoscience, as we look for, the colorations, of these different insects can be understood basing on the optical nanoscience. So water collecting beetle bags and Duncan beaks, and the list go on. So these are some of the things which were there getting mimicked by the scientists looking for the mother nature. As on date, we had so much of development in the field of nanoscience, nanotechnology. Now people are looking for the living cells, and DNAs are getting copied, proteins are getting formed, the complex hormones are getting manufactured these days based on this technology. So as we talk about these hormones, they communicate between different cells, tissues, and organs within the body. And the protein formation is basically a biological process where genetic information encoded in DNA is used. Okay, on a similar note, we check out for the DNA sequencing. It is revolutionized over the understanding of genetic, medicine, and biology, and this enables us to diagnose the diseases, advancing and advance research, and improvising human health and well-being. So this is to the very latest developments that we have in the field of nanomaterials, and hence the nanotechnology is not new anymore. Our ancestors, they made the nano resin being red in color. So all those ancient stained glass makers, they knew, and they have made use of the silver and gold nanoparticles of different sizes to realize various colors. That means to say, knowingly or unknowingly, our ancestors were there to work with the nano materials. Now, coming to the modern era of nanomaterials, this has begun in the 20th century due to the very advancements that we had in the fields of nanomaterials, material science, and the microscopy. Exactly speaking, the discovery of carbon nanotubes, right, in the year 1991 has led to the interest and research in nanotechnology. So nanomaterials of today, they play a pivotal role in the fields of electronics, medicine, environment, whatnot. Almost all the areas of science, engineering, and technology are being touched upon by the very developments that we had in the fields of nano science. So, in one simple word, we can define nanotechnology, which is an ultimate study of nanoscience. It is nothing but it has the revolution of endless possibilities. Now, as we are here to discuss about the nanoparticles and nanomaterials, it is to be understood, in principle, what are nanomaterials in particular? Nanomaterials are the structured components with size less than 100 nanometers, at least in one dimension. And so is the way to make you go clear of what we mean by nanoscience. It refers to the study, manipulation, and engineering of matter, particles, and structures on the nanometer scale. And basing on the very concepts of nanoscience, if you can devise something and which is so useful to the society or the mankind, we delve into the very fundamentals of these nanomaterials by what they are, considering their principles. As is being already mentioned, nanomaterials are with few special attributes. Those special attributes of nanomaterials, right, will be basically due to two principles. They are a relative surface area, and the next one is the quantum confinement. This is where the nanomaterials mostly differ from that of the bulk counterparts of them. Coming to, we see here, as the size gets altered, we'll have the surface area to get revised. So nanomaterials offer good surface to volume ratio or a relative surface area. It is basing on that they remain being highly reactive. Now coming to the very point of quantum confinement effect, right? It is to understand the randomness of electron and to restrict its motion in specific energy levels, right, which are called quantum, which is called quantum confinement. The quantum confinement mostly arises due to the revision in the atomic structure. Okay, that revision in the atomic structure directly will influence the energy band structure. As we see from the very pictorial representation there, a nanoparticle of 6 nanometers dimension will have the very band structure, right, as indicated. As we go the size of the nanoparticle, we see the very confinement happening. That is what we mean to say. The randomly situated electron has to be restricted by its motion by specific energy levels. That is where the confinement happens. And as the confinement happens, there will be, right, discreteness with reference to the energy levels which occur over there, basing on which we'll have a set band gap with reference to those indentations. Okay, as we move on from 6 nanometers to 2 nanometers, we see the confinement happening in terms of width and the band gap increasing. Okay, these are the two principles basing on which we can understand the very applications of nanomaterials. So if you consider a semiconducting material where the particles radius being put to the Bohr exciton radius, right? The material's properties always go highly size dependent. Okay, so what we need to understand over here is, as the dimension of the nanoparticle reduces, the discreteness of the energy level increases, and we'll have the band gap to get widened up. Now coming to the very classification of these nanomaterials. As we were there to define the nanomaterials, it is being so told to you that these are the materials which will have the nano indentation in any one of the dimensions. That is the one which has to be underlined. So based on the dimension, these nanomaterials are broadly classified into 4 types. Okay, 0-dimensional, 1-dimensional, 2-dimensional, and as well as the 3-dimensional. Then comes the point, what we mean to say the 0-dimensional. So all that length, breadth, and height, if they are being confined to a single point, like that of the nano dots, we refer to them as 0-dimensional nanomaterials. So if we have any one of the parameters like the length, breadth, or height, okay, being confined to one dimension, as is the case of thin surface coatings, we refer to them as 1-dimensional nanomaterials. Similarly, if we have the length and breadth, right, being under consideration, as we check out for the dimensions of nanoparticles, we refer to them as 2-dimensional nanosystems. So the best suited examples could be the nanowires and nanotubes. Similarly, right, for all the parameters like that of length, breadth, and height, right, are being taken into consideration, they are the ones which we refer to them as nanoparticles. So mostly the nanomaterials may have to be received with reference to their nano indentations, and their nano indentations may have to be also studied with reference to their dimensions. Now, based on the very classification, so we have a pictorial representation here for 0-dimensional, 1-dimensional, 2-dimensional, and 3-dimensional systems. We can check out here the core shell nanoparticles. They come under 0-dimensional carbon nanotubes, as some of you might be working with. They come under 1-dimensional graphene-based composite structures. They come under 2-dimensional. The 3-dimensional systems, as we go considerative of length and height, right, as is the case with mesoporous composite electrodes, right, they come under the 3-dimensional nanosystem. Now that we have come to know about what are the tiny particles, what we mean to say the nanomaterials, and what we mean to say towards the nanoparticles, to understand them better, we also may have to understand various synthesis aspects of nanomaterials. Broadly looking at the various synthesis aspects of the nanomaterials, as many of you know, right, they are to be received in terms of top-down and bottom-up approaches. So top-down approach, it is a bulk material, will get ground to powder, and thereafter the nanoparticles. In the bottom-up presentation, the nanoparticles, they formulate into the clusters, and then the atoms are the molecules. The very figure is self-explanatory by what we were there to explain. So top-down approach can be received in terms of preparing a statue from stone. Okay, so we'll have a lot of wastage in the process, wherein bottom-up approach can be received with reference to an example of we building a wall, right? Everywhere we make use of the bricks, keeping them one after the other, one over the other, so as to come up with a big structure. Okay, so these are the two examples we are basing on which these two methods can be better understood. Now coming to the very other methods of we checking out for the nanomaterial preparation and by putting them under top-down and bottom-up approaches, right? We have physical methods, chemical methods, biology methods are the biological methods. And it is given out here, the list goes on. There are different physical methods, out of which the easiest and the method that one can understand is the ball milling. And so is the way the chemical method of synthesis of nanomaterials can be understood from the different methods which are being cited over here, and one of which is the sol gel method, which we will be highlighting as we take you to the other slides of presentation. On a similar note, to be with the green technologies today, we are also there trying to prepare the nanomaterials and nanoparticles from biological methods too. Okay, wherein we use the very extracts of the plants or the microorganisms, algae and enzymes to prepare out these nanomaterials. Okay. Now this is what we receive looking for the ball milling. As is being already mentioned to you, is one of the simplest methods basing on which one can prepare nanomaterials. Okay, we'll have the fine powders of the bulk samples as we put them to the very cylindrical vessel that we have, making them get rotated with reference to different RPMs, and we'll have this size reduction to happen in the process, and this can produce nanomaterials of different sizes and the shapes to the very desired presentation of us. We can operate at this ball milling. Though it has few set disadvantages, well, one such great disadvantage is the contamination in the process of preparing the material. Okay, but the materials that are being prepared from this also have few good applications in the fields of the electronics, the catalysis, and in general the materials science. Now, the chemical method that can be used for the very preparation of nanomaterials is the simplest, is the sol-gel method. So here we'll have a sol being prepared, which is nothing but a colloidal suspension of nanoparticles, and that will get subjected to the hydrolysis and condensation process and the sol will get turned into gelation. Some of you might have taught this very point to our students, and this is one of the easiest methods of preparing nanoparticles of any desired sizes. Okay, the very steps of preparation are depicted in the figure. Right, the gel can be further subjected to the drying, calcination, and the other treatments to have nanomaterials of different presentation. The next slide, you can see that. So we'll have the metal oxide, alkoxide solutions, and if they can get coated on a very surface or the substrate, they will form into a xyrosol film, which is a network of arrangement of nanoparticles, okay, on a surface. When we get them subjected to heating, we'll have very dense film formation. Now, if you take those metal oxide solutions, get subjected to hydrolysis and polymerization, we'll have all to happen and put it to the, we'll have ceramic fibers to derive. Now, this sol, when it is being subjected to the precipitation, okay, we'll have uniform particles with a sort of matrix of arrangement of atoms thereof. Now, when this sol is being made to be a gel, which need to be referred to as a wet gel, and is being subjected to evaporation, okay, we'll have that xyrosol presentation. And when that is being heated, now we'll have dense ceramics to derive. Now, from that wet gel, if you extract the solvent, we'll have the very network of nanoparticles which will form into aerosols. And these aerosols are the ones which are known as the lightest solid materials known to the mankind. Okay, that can be derived using this sol-gel technique. Okay, so to the very desired presentation of us, one can prepare the nanomaterials going by the various sizes of nanoparticles from the sol-gel presentation. Now, as the theme highlights the very making of nanomaterials, and as I have mentioned to you already, there are physical, chemical, and biological synthesis techniques. So, physical method we have come to know through ball milling. Chemical method is from the sol-gel technique, and now the green synthesis. What's exactly right? My fellow speakers will be highlighting this up and on the other session. But to bring it to your notice, as we are addressing the making of nanomaterials, so this forms the general overview can be received from the very picture that we have on this slide. We'll take the different parts of the plant, the leaf or the flowers, the roots and the fruits. We put them to the metal salts, and we can think of having nanoparticles with different sizes and the shapes, which are very much useful in going for the applications in the areas of medicine, agriculture, wastewater treatment, photocatalytic reactions, etc. Okay, what exactly we do over there, what exactly happens there in the process of we preparing the nanoparticles from the green synthesis is from the other pictorial representation here. Okay, we'll have three phases. One is the reduction phase, wherein the metal ions will be made to be with phytochemical containing the OH group over here. And next comes is the growth phase, wherein these phytochemical, and nextly we'll have the stabilization. So as we see the stabilization to happen, these metal nanoparticles will get encapsulated by these phytochemical presentations. Okay, so that is how one can think of, right, having the preparation of nanomaterials from the green synthesis, and this is of good importance as we check out for the environmental concerns of we preparing the nanomaterials. The next one, then we have these nanomaterials and with few nano indentations, and they have few special attributes. And what are the properties by which they have a good recognition, and what are the properties which will get subjected to immediate changes as a bulk material turns out to be a nanomaterial? If you want to understand, these are the vital properties. One is the structural properties, the optical, electrical, mechanical, and magnetic properties. The structural properties, as we look out for, as is being already underlined, these nanomaterials will offer right good surface to volume ratio. The next one is, as they become nano, they remain being highly reactive. And the third point is, they will be there with strong binding among the different surfaces, and as we see them, so there will be a subsequent changes by the very morphology or the topology and the changes in the crystal structure. So as researchers, we may have to study those topological, morphological revisions, right, with reference to the crystalline systems. And the optical properties will also get subjected to immediate revision as the bulk materials turn to be nano. So just to make you understand the point, very simple. Light, as it incidents on the material, either it will get absorbed or it will get scattered. And if you want to see these nanomaterials really absorbing the light which is there to get incidented on them, those nano indentations shall be of the size 20 nanometer. The process will be so dominant. Similarly, as we check out for higher order nanoparticle systems of the dimensions, say 100 nanometers, scattering is prevalent. Now, designing the nanomaterials of different sizes, we are going adopting any of the physical methods, chemical methods, or the biological methods, and one can optimize the absorption and scattering abilities of those materials. Here in our research lab, This is what precisely we were there to do. We were there to prepare different nanomaterials, which has the nano indentations of different dimensions, and we have studied the absorption and scattering aspects of them to discuss about their optical behaviors. Okay, so as is very much present on this slide, as we go down of the size of the nanoparticle, right, the fluorescence happens. Fluorescence of cadmium selenide nanoparticles, as the particle size goes down from 610 nanometers to 548 nanometers, we see the different fluorescent presentations of the cadmium selenide nanoparticles. So similarly, electrical properties, magnetic properties too will get subjected to very good revision, right? Because the nanoparticles remain being highly reactive and they'll be with good electrical conducting abilities. And what is the beauty with this aspect is we can have or we can tailor make the nanomaterials based on the desired conductivity. Okay? Such is the thing which can be realized in the due course of time. As we were there to look at the materials by what they are, we never were there to find them with different conductivities. We can't alter their conductivities at any point of time. But whereas, as we can see the nanoparticles, go about them and try to manipulate their movements and sizes, we can think of designing a material to the very suit of us considering a particular applications. We mean to say one can tailor make any functional material, smart material, or one can engineer the materials in general. And as the bulk materials turn to be nanomaterials, the magnetic properties will get revised, and those magnetic materials, mostly the magnetic aspects, will go enhanced. And non-magnetic materials also will become magnetic as we go decisive of the particle size. So mechanical aspects like hardness, elasticity, adhesion and friction will improve as the size goes down. So lubrication properties will also get enhanced. Ductility with reference to temperature will be very high. These are some of the aspects which are taken care in our research laboratory, looking for the study of lead-free ferroelectric materials, and we have studied their mechanical aspects and in the fields of lubrication and ductility, improving their ductility. And as our theme says, the tiny particles, I just would like to just slightly go deviated from the very presentation. Tiny wonders, I prefer calling them as tiny particles, right? Big future, I prefer naming it as big wonders. Tiny particles are in a position to cause big wonders, by the principal madam and the other speakers, emphasizing on the nanomaterials and nanotechnology. So nanotechnology can be applied in different areas, and these are some of the areas which are being highly benefited after the invention of the nanomaterials or from nanotechnology in general. So we have these coatings, drug delivery aspects, the fuel cells, the sensors, whatnot. We have the biosensors, the supercapacitors, the lithium-ion batteries, right? And water purification is also with reference to this particular technology. So these are the different areas wherein we have the applications. Let me highlight some of the areas some of the applications considering few special areas. So one is all about advanced electronics. So advanced electronics, we can have smaller, faster, and more efficient electronic devices, right, these days. All are due to the developments that we have seen in the field of nanotechnology. And these can enhance the very performance of these gadgets and duly reducing the power consumption. This is one area wherein our scholars are working, considering materials will be of uh, pure memory storage. So coming to the very point of biomedical presentation, so these nanomaterials, right, are into the medicine with the technology in using these nanomaterials for drug delivery systems, imaging agents, and are also into the tissue engineering these days. So what will happen as we make use of these materials there is we can have targeting, controlled drug delivery, and improved biocompatibility and revolutionizing the healthcare treatments. As it gets home, it will cause a localized therapy there, and we can see by other image the improved presentation of it, and later killing the cancerous cells, causing, right, I mean, any
We are not getting the audio, sir. It is muted. It is muted.
System lab.
Sir, me unmute system, sir.
Am I required to share the PPT again, sir? Hello?
Please repeat the what the slide once again, because there is a audio problem. So we request you to kindly
Okay,
repeat.
no issue. Unmuted. Shall I share? If the presentation is on, sir. Where is the PPT, sir? Is it visible now, sir? From this, if you want me to explain biomedical applications, I'm done with my biomedical applications. If you want me to repeat that, I will repeat. Hello, sir. Now unmuted, sir. Open the PPT. Hello. Am I audible now? Is the slide visible? If I'm going for my slide mode, presentation mode, audio is automatically getting switched off. That is the problem. Shall I check once? Press the very. Now it is okay. Am I audible? Audible, sir? Sir, coming to the very area of material science, we had tremendous development because of the different nanomaterials which we were there to develop with time, and they are mostly the lightweight, durable, and high strength materials which we prefer using in aerospace, automobile, and construction industries. Just to make the people understand, so go for the automotive industry. We all know about these cars. Every part of the car is somewhere or the other is getting prepared in terms of the usage of nanomaterials in that way, this way or that way. So fuel cells, self-cleaning films, the heat shieldings, polymer glazing, okay, the fuel additives, nano lubricants, nano coatings, nanomaterial tires. So the catalysts, right? Nano grained engines, nano sensors, and nanopolymers. These are the ones which are getting richly made use of in the automotive industry these days. Okay. Now take for example the civil engineering works. They are just like that. All these 21st century buildings that we have at different places all across the globe are due to the developments that we had with reference to the nanomaterials, looking for their mechanical properties and the other novel functionalities. Now coming to the very point of energy storage and conversion applications, these nanomaterials, they are playing a crucial role in developing high-capacity batteries, supercapacitors, and fuel cells. So as we talk about the energy, we are going to run short of energy in the days to come. our governments are taking precautionary measures to combat the energy crisis. Now, to be with that, the present generation people may have to make use of the energy resources so effectively and getting that being converted. Now, as we check out for energy aspects, we receive it in terms of these different presentations: energy generation, energy conversion, energy storage, and we have energy saving and energy transmission. All these different areas, a lot of research is happening, and we are into the very energy generation point. Right in our research lab, we are working with triboelectric presentation, piezoelectric presentation of energy generation. We are also into the energy conversion, checking out for perovskite solar cells, and towards it, we will be either making use of the one-dimensional or two-dimensional or three-dimensional nanostructures. So not that we just will have the generation, we also need to check for the energy storage, and that energy storage is happening these days with reference to these supercapacitors. And we are also into the area of nano lubricants. We have designed few nanomaterials which can act as good nano lubricants, solid state lubricants, we are referring to them as, and they are also being taken up, and they'll enable us to be with the energy saving. And next one is the quick transmission of energy. From quick transition of energy, we talk about looking for the superconductivity and the insulating materials development. So the energy storage, all these different nanomaterials, they have the ability to store the energy, and they'll have different aspects of charge and discharge rates, and overall performance of energy conversion can be spoken about with reference to these nanomaterials. Now, another area is the catalysis. They serve as efficient catalysts for chemical reactions, as is being already mentioned. These nanomaterials with nano indentations will remain being highly reactive, and they here will be there to act as the catalyst. We refer to them as nanocatalysts, and these catalytic conversion, converters we use in vehicles, industrial process, and renewable energy production. So these catalysts, they just will enhance the reactions and go reduced of the energy requirements and minimize the waste. So here in our representation, it's given the minimum chemical waste, reduce global warming, they contribute to the optimum feedstock utilization, energy efficiency will be boosted, safer catalysts and reagents, and can be with cost-efficient presentation. And coming to the very point of information technology, they are getting used for data storage, quantum computing, and in photonics. Okay, and these will enable us to see the miniaturization of that materials and improve the data processing speeds and facilitate the emerging technologies like quantum information processing. Okay, this is one area which is being highly benefited as we were there to see developments in the nanomaterials. Okay, the layered ferroelectric materials are the ones which are getting used as ferroelectric random access memories these days to enable miniaturization in the first step, and to have the good data storage and facilitate this quantum computing in general. And coming to the point of applications in textile industry, they have revolutionized this textile industry. We can see here the wearable sensors, health monitoring in terms of our smart watches of today. We are just monitoring everything. The smart circuits, antimicrobial presentations, which we have used during the corona period, the wrinkle resistance, water repellent systems, the self-cleaning systems, right? And UV blocking systems, considering the textile industry, are being promoted with reference to these developments in the fields of in nanomaterials and in simple the nanotechnology. And coming to the other point, food and agriculture, the nanomaterials have become so important in going for the applications in food pieces. Okay, one of our co-speakers will be talking on it, I think, in the afternoon session. Right, nanotechnology in agriculture will have so much to cause for us. We see the crop growth, crop improvement, crop precipitation. Hello? 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 Audible. I thought it's not audible. Shall I proceed, sir? 5 more minutes, I'll conclude. Shall I, sir?
Okay, proceed, sir.
So, soil enhancement, tolerance, we can see the crop yield by the usage of these nanoparticles, germination, healthy soil, right? And we can talk about the nano pesticides and these transgenic plants, right? By we have been going for the mutations of them and the nano sensors. So much is happening in the agriculture field, considering the nanotechnology there. And environment, the pollution can be combated looking for nano remediation. And this is a slide which help us to understand the nano remediation towards air, soil, and water. Different nanomaterials at different scales due to the developments that we were there with in the field of nanomaterials. Okay, they create intelligent systems with enhanced capabilities of sensing, decision making, and automation. Okay, and as we check for this AI and robotics, we are going to see random, rapid, and radical changes in the fields of industry, healthcare, and even everyday's life. Okay, as we look for these tiny particles, mining their wonders of them, one may have to go considered of safety and ethics aspects of them too. Okay, and we have this image which will explain the findability, accessibility, and reusability of the data. Okay, on at the output. So all these different systems, they shall work together on an harmonious note, right, from input towards the output and output to remain being so good with the utilization of nanomaterials. Okay, most of the research is happening in this direction as we make this happen to see the futuristic developments making use of the now, coming to the last point of presentation, the future of nanomaterials may have to be understood in terms of 4 distinct generations. Okay, currently we are experiencing only the first, maybe the second generation of nanomaterials. Okay, first generation of nanomaterials deals with the material science and enhancement of the properties of the materials which are under study. So that is there happening all across the globe, right, in general. Now the second generation, right, we make use of these active nanostructures which are bioactive to provide the drug to the specific target cell or the organ. So the target drug delivery is also happening, which comes under the second generation of usage of these nanostructures. And now the complex advancements are going to be in the third and fourth generations, right? Starting with an advanced nanosystems, narrow robotics, moving on to the molecular nanosystems to control the growth of artificial organs in the fourth generation of nanomaterials. To that extent, one can imagine as we look for the nanomaterials, and as is being rightly said by our famous scientist Einstein, imagination has no bounds. Okay, and as we check out for these nanomaterials, looking for their wonders, and they causing us a better future, one can go imagine to any extent is what is being installed for us in particular. Now, not that we check out for the study of these nanomaterials simply, they can cause us good nano careers. So we have these different areas, especially for the students who are there listening to this talk, okay, can pursue their careers in these different frontiers. One is the design, the development, the national security, technical support, the research, management, the packing, energy producing, clothing design, the public service, fabrication, patent attorney, the environment, sales, the teaching, testing, construction, and many more. These are some of the areas which can be immediately taken into consideration looking for a career in the nanotechnology. Now, so what is that we were there doing? So we have made few attempts to have of lead-free ceramics. We are studying, preparing them up from different methods of solid state, diazomine sol gel, hydrothermal. We have characterized the bulk and the main nano particles, looking for memory devices and sensors. And similarly, we are also studying the semiconducting nanoparticles, subjecting them to different annealing temperatures, looking for their suitability in the fields of optoelectronics, soft magnetic materials, solid-state lubricants, and nano additives. And one more scholar is working in the area of ferroelectrics with NBT and NBT-BT composite presentations, looking for the tribological and optoelectronic applications. As is being already mentioned at a point of time during the presentation, one of our scholars is working with the cobalt copper ferrites, looking for hyperthermia applications. And as on date, we are with the multiferroic materials, looking for the very systems mentioned there, SBNCF, SBNZF, and nanocomposite systems main. And we are in a pursuit of looking for diverse applications in the fields of memory devices and optoelectronics. So from the entire presentation, it can be so summarized that these nanoparticles can cause us very good developments in the days to head. The knowledge of the tiny particles is highly indispensable, without which the modern developments, technologies never ever can be that easily be understood. And as is getting said, this is going to be the futuristic technology. I advise all the students who are listening to us and the faculty members too to pursue their careers and research in this particular area, so that we can go acquainted of the latest and the latest developments which are happening all across the globe, considering this particular, considering these materials or the technology known as the nanotechnology. Finally, I just have a mention to you all that I learn to give not because I have much, but because I know exactly how it feels to have nothing. Okay? Now with that, we conclude our presentation. Now the forum is open for the questions.
Thank you, sir. Thank you very much for sharing your expertise and insights with us. Your passion for physics and your ability to simplify complex concepts have enlightened and inspired us all, sir. Your presentation has undoubtedly deepened our understanding of nanomaterials, sir. Thank you very much, sir. Thank you, sir.
Thank you. I thank the principal madam and the team members of the D.S.Govt Degree College for securing NAAC A plus status. I know what it means, as we work for the same at our institution too. Okay? Thank you one and all for the opportunity given.
Thank you so much. Thank you. Thank you.
Okay. Now I request Dr. T. Anil Kumar.
Sir.
Thank you very much. I request Dr. T. Anil Kumar, Assistant Professor of Krishna University, to deliver his lecture on tiny wonders, big future for the nanomaterials, for the future of nanomaterials. And I would like to give a brief note on the profile of Dr. T. Anil Kumar. Dr. T. Anil Kumar, Assistant Professor of the Krishna University in the Department of Chemistry, who published around 15 research papers in the international journals having Scopus Index. And he published, he did his research in the synthesis, characterization, and catalyzation activities using carbon and silica from bio-waste. And he published his international research papers in various international journals, like International Journal of Special Education, Journal of Ultra Chemistry, and IOSR Journal of Applicable Chemistry, like that. He is a good research scholar. He has received Best Teacher Award from the Usharama Engineering College when he was working there as the assistant professor. And he is a member in different chemical societies like IACD, Indian Association of Chemistry, ICSSR, like that. He is a member in different chemical societies. And now I request Dr. T. Anil Kumar to deliver his lecture on nano nickel on bio-waste adsorbents and applications. It's a pure nano nickel bio-waste adsorbents and applications, and his topic. And on behalf of D.S. Government Degree College, Women Ongole, I request Dr. T. Anil Kumar to deliver his lecture. Thank you.
Yeah, thank you so much. Am I audible, sir? Hello.
Yes,
my voice is audible. Yeah, thank you so much. First of all, good afternoon, all of you. So, thank you so much for inviting me, the part of the national webinar, Tiny Wonders, Big Future, Making and Understanding the Nanomaterials. The outset, I would like to thanks to Dr.D.KALYANI, Madam, Principal Madam, and also organizing committee, Dr. M. Srinivas Reddy Sir, lecturer in chemistry, and Dr. K. Pratap Sir, lecturer in chemistry, and Srinivas Rao, Sri B. Srinivas Rao Sir, lecturer in physics, and also Dr. N. Manjula Bharati, Madam, lecturer in physics. Thank you so much for inviting me as a part of this national webinar. So, just a minute, I will share my PPT. Sir, my PPT is visible? Yeah. So, see, the previous session, Kiran sir is already discussed broadly. Yes, sir. Yes, sir. Now, okay, sir?
Okay. Audible.
Yeah, okay. File is already, it's a full, I shared full screen, sir, already. Just. Yeah, sir, now it is okay, sir? Yeah, thank you. Present a brief on the nano nickel on bio-waste adsorbent and a few application of this. So already know that the nanomaterials which play important role in the society, present society. So I would like to say that now we are living in nano era or nano age instead of using modern age. So instead of using modern age, we are just at present in the nano age. So you already know that the nano, that is called 10 to the power of -9 meters. So what is a nanomaterial? Sir already explained about briefly. I mean, not briefly. The vastly explain about this. The nanomaterials are commonly defined as a material. The average size is less than 100 nanometers, and which is having at least one dimension. So, right. So this is just example for the average width of human hair in order to almost 1 lakh nanometers. So the smoke particle is almost 100 nanometers. You just imagine how tiny particle of the nano size. Okay. So this is also sir explained. So broadly, why the nanomaterials are used for? So here, when we decrease the size, so this is the basic and the key of a particular nanomaterials. When we decrease the size, we can increase the surface area of the particular material. So this is the key point to use this nanomaterials in different fields, like of course, electronics, optoelectronics, biomedicals, biotech delivery system, catalyst, safeguard medical, etc., etc. So that is the main particle. So the nanotechnology exploit the benefit ultra size, enabling the small particles are visible, and the transparent coating are small particles are very weight efficient. I will explain it. So the behavior of the nanometal maybe depends upon the surface area of the particle composition itself. So the relative surface area, reactivity, the strength, and the electrical property. This is the most important keyword. So when the surface area increases, also the most important, that is the enhance the reactivity, the strength, and not only other property, electrical properties, but all other properties are increases. So if you can observe this picture, so the first one, see this, just a minute. The first one, the 10 micro size weight of it covers. So the same thing, or we can decrease the size of the almost 20 surface area. So the large particle do not cover much surface area. So when they decrease the size, so it covers the entire area. So when you know very well, most of the science people know that when increase the surface area, the selectivity is increases. When the selectivity increases, the productivity is increases. So that is the vice versa, depends upon the factors. So the nanoparticle equal mass of the platelets particle provide through the cover 1 into 106 times more than. So this is the power of to make the size, small size, that is called nano size. So you know very well, basically the characterization of the nanoparticles, there are, in order to characterize the study of the future, such as a composition, which type of the composition of the nanomaterial and the structure and where, because here when we know about the size and shape and the particle, so wherever it is used, in order to that we need to find the characterization of the nanoparticles. So these are the general, I mean not these three, there are so many methods, but these are the main characterization methods, that is called first one is scanning electron microscopy and transmission electron microscopy and BET Brunner emit Teller analysis. These are the general three characterization methods in order to determine the structure and topography and the size, shape, volume of the nanomaterials. Okay, right. So, and coming to actual topic of today's presentation, my presentation, that is called nano nickel on bio-waste adsorbents. So I will explain very briefly it is. So here, the simple thing, we are preparing the nanomaterials is distributed or bio-waste adsorbents used to support to the nickel nanomaterials. Okay, so here that just briefly about the what you can say, adsorbents. So you know very well about that. Adsorbent is a substance usually porous in nature with the high surface area, which adsorb the substances into the surface area into molecular force. So this is called as absorption, you know very well, and this is called as absorption. So where the adsorb particular adsorbent. So this is the key to use the nano nickel materials used on especially bio-waste material which we prepare. So that means the waste which are outcome from the bio, like either plant or animals, or here the most of the agriculture, biomass production from the agriculture, like rice husk, coconut shells, and bagases, and bamboo, wood chips, etc., etc., and forest generated biomass or industrial waste, sawdust, papers, cardboards, black liquor, or urban waste like municipal solid waste. So these all are waste which outcome from the bio. So in that we choose rice husk as a bio waste material in order to use adsorbent as a nano nickel catalyst. Okay, so very well meant for produce. That is why Andhra Pradesh is also called as rice bowl of India. So most of the, of course, in Andhra Pradesh, we produce more and more rice. That rice husk is the one of the waste which outcome from the waste. Very well, rice husk is used to many by-value byproducts and potential source to especially energy. In villages, they are used to rice husk as in their especially producing cooking purpose. Cooking purpose they used. So apart from that, we use rice husk. So this is actually our work plan. So that raw rice husk we used to prepare rice husk hash and silica and activated carbon. So these three materials we are produced from the rice husk. So, and here the rice husk ash and silica and activated carbons, these are we used as adsorbents or supports to the nano nickel materials. So nano nickel metals. Okay. So the average chemical composition of the rice husk ash, of course, almost 81% is silica is present, and almost 8.2% is carbon. Carbon is present in the rice husk ash. And going to the pyrolysis, that is called temperature decomposition. We produce rice husk ash and activated carbon and silica. So where we can characterization these material by the first one is surface area and pore size distribution. So also that we characterize with XRD and FTIR, etc. So these materials used to catalyst supporters or catalyst adsorbent, and we just observe the different reactions like carbon dioxide adsorption or dehydration of the alcohols, hydrocyclization and hydrogenation. So here we are explaining, I just want to convey only, explain only hydrogenation reactions. Okay. So this is the background work what we done before going to bio waste material like rice husk used as a adsorbent for nano nickel N4. It means RH means rice husk, N means in the presence of nitrogen, atmosphere presence, and 4 means the temperature indication. So here we are using 400 degrees centigrade. So these all are subjected to characterize in order to determine the surface area. We go for the beta analysis. So here these are the surfaces area beta analysis, like surface area, PV, that is called pore volume, and average pore diameter. So we already said that adsorbent is naturally the porous nature. So that is why we need to find the surface area as well as pore volume and pore size distribution. So here and 1, 2, 3 like 800 distance like this in air presence, and here NW means nitrogen and water. Water means the steam. So here, among all these samples, we can get a rice husk with the nitrogen and water presence at 600 degrees centigrade, which is having highest surface area. So this is the material or the sample we prepare in our laboratory for the using of adsorbent for the nickel catalyst. Of course, in the market, there are so many adsorbents are available. But here we choose bio-waste metal. Why? Because basically it is a waste and it is a biocompatible and non-toxic. Because of that reason, we choose this. So here, rice husk with the nitrogen and water at 600 degrees centigrade, which shows the highest surface area, almost all 311.5 meters per grams, and also the pore volume and pore diameter. So this material we used for other applications like this one, like compared to studies of CO2 exhaustion studies, dehydration of alcohols and extraction of what can say right. So here the conversion of levulonic acid to gamma valolactone and the same nitrobenzene to elated preparation. So only this work presentation now here is already carbon dioxide absorption and dehydration of alcohols. We already published in the particular paper. Okay, so what the first one is extraction of silica from rice husk and activities of nickel silica catalyst, conversion of levulonic acid to gamma valolactone. See here, levulonic acid to gamma valolactone reaction is already there and in the presence of nickel. So here we are observing how our bio waste adsorbent used for the nickel catalyst and especially how the nickel is spread on the particular rice husk material, etc. So that is only we observe. So the main highlights of this work, the extraction of silica from the rice husk and followed by, so we take the nickel catalyst and in the size, and that is supported as a silica extracted rice husk prepared by the wet pigmentation method and variable nickel content ranging from almost 5 to 40 weight percentage ratio, and these are used to observe the conversion of levulonic acid to gamma valolactone, especially in vapor phase atmospheric pressure. So this is already set up in our laboratory. So and here mainly observing the catalyst have been characterized by the different technique like XRD, that is X-ray diffraction, BED, Bronner emit LR for surface area, pore size distribution, and also TPR, temperature program reduction. So XRD pattern, especially the silica present in the incorporated nickel. So in order to that find, we used XRD and creatine absorbed by especially for nickel created Lewis acid acidity nature and catalyst like here 30 weight percent nickel rice husk silica have a good show result almost 85% yielding capacity and almost 91% of conversion of levulonic acid to gamma valolactone at the temperature of 250 degrees centigrade in vapor phase ambient conditions. So the highlight, the high activity of can be attributed to high number of surface activity nickel species of due to the Lewis acidity created by the nickel. So this is the general highlightation of the particular reaction application. So just we observe how the silica take 10 grams of rice husk char was preheated, that is mixed into 200 ml of 1 molar HCl. And the suspension was boiled for 3 hours under the refractory condition and stirring well, and then filtrate and washed with dilute water until the pH and dried for until the neutral pH here, and dried for 15 hours at 120 degrees centigrade. So that is filtered. That filtrate is added to with the 200 ml of 15 weight percentage of sodium carbonate solution, and again it is reflex for 4 hours, and solution is added to with at 24 hours at 120 degrees centigrade. So now it is prepared as especially activated carbon, and we can get filtrate. So from this filtrate we can prepare the silica. So here we can prepare both activated carbon and silica. So the filtrate, the solution which contains sodium silicate and subjected to carbonization. The process required with silica. The solution heated around 80 degrees centigrade under the continuous flow of carbon dioxide for 1 hour to stop and cool down, and the silica is precipitated in the filtrate and dried, and that is labeled as a rice husk silica, that is called silica. So here you carefully observe almost all. So in order to prepare one sample, that is called 1 gram of silica, or 1 or 2 or 3 grams of silica, it takes almost here 3 hours and 15 hours plus almost 18 hours and 4 hours. 18 plus 4, 22 hours plus 24 hours, followed by here 1 hour and 24 hours. That means almost all 3 to 4 days it takes in order to prepare this rice husk silica. Okay, and followed by the catalyst preparation. So here we are preparing nano nickel catalyst by using wet pigmentation method. So that is called nickel nitrate hexahydrate. So this is used as a precursor for the preparation sample, that is called N20 and 30, 40 weight percentage ratios. Okay, so after that, heated on a hot plate at 80 degrees centigrade to remove excess water, and solid mass was dried at 100 degrees centigrade for 12 hours, and it is calcinated at 400 degrees centigrade for 4 hours. Now it is labeled as a namely we can call 5, 10, 20, 30, 40 weight percents, what we mentioned the above. So that is a series or sequences of weight percentage of nickel we choose to mix the rice husk. Okay, so here you just observe this. This is actually the sample, raw sample, that is called silica, which extracted from the rice husk, and the surface area is 595 and the pore size is 3.12. So for this you just mix 5 weight percentage of nickel. See this 474.2. That means the surface area is decreases, because here the porous nature of the rice husk silica, which is filled by the 5% of nilica. Because of that reason, the surface area is decreases. You take the 10 weight percentage, so here 452. Likewise, the surface area is decreases because the pore blocking of the nickel on rice husk silica samples. So this graph is shows that the decreasing of the surface area by weight percentage like 5, 10, 20, 30, and 40. So slowly decreases. Right. Okay. And at the same time, pore size also decreases. Okay. So why? Because the adsorbent already said that it is a porous in nature. So here the metal, nano nickel metals are blocking the pores. So because of that reason, the size decreases. Okay, so these are the extraordinary pattern. If you carefully observe, A, B, C, D, E, that is called 5% is 10, 20, 30, and 40%. 5% is of nickel silica catalyst, so which is having low intensity. Okay, when the percentage of nickel increases, the intensity is increases. So that is called the pattern, especially the theta degrees of 42.2 and 53.3, 53 and 78. So the intensity is increases slowly. Why? Because the percentage of the nickel is increases. Okay, so these are, you can clearly observe that, and that means the XRD pattern clearly observe that, give that information that the percentage of the metal. And here we use that FTIR pattern that is called the functional groups present in the catalyst that is called 3734 and 36.4 centimeters. That is called hydrogen bonded surface Ceylon groups are present and absorb the water molecules, and especially silica, oxygen, silica, metal, O metal, mom groups are present in this catalyst. We just observed that this pattern. Okay. Likewise, all the samples. Okay, this is called pyridine absorber FTIR, especially to find out the Lewis and Bronsted sites present in the sample. So, right, this is the pattern 1419 centimeters inverse and 1455 centimeters inverse. It shows that Lewis sites, and it means the nickel which produce the Lewis acidity nature to convert the levulonic acid to gamma varolactone. Okay, and these are the TPR profile. So especially this TPR temperature program profile, which shows that the how much temperature with almost able to withstand a particular catalyst. So here the nickel oxide, that is called nickel, is converting into nickel oxide at 400 degrees centigrade. This pattern will clearly show that. Okay, so here in order to withstand the catalyst when the rise the temperature, so without any deformation. Okay, so this is the activity study. This is general setup we already established in the laboratory. This is a reactor that is called what can say reactor. Generally, we use the fixed bed material that is called biomass plus catalyst. Here, biomass means what are the sample we take in, and the catalyst is nickel catalyst. So that is placed in this, and in that we just flow the inert gases like hydrogen or nitrogen presence may be used, and here the temperature controllers, and here feed pump and the furniture reactors are used. So here you just observe the 1 gram of catalyst placed over sandwiched bed, 2 quarts wool plugs placed in a middle fixed tumbler reactor with made up of prayer and hydrogen flow, what we used conditions. So the reaction was carried out the temperature range from flow rate of a particular reactant that is called using hydrogen gas as a carrier. So here in the feed pump, in order to supply reactant, what is the reactant here? Levulonic acid, obviously. So the levulonic acid is supplied only for 1 ml per 1 hour. Okay. So here the reaction productions were collected. So here the reaction was completed. That means what? The levulonic acid is converting into gamma valolactone. So here the outlet, and which is collected in ice cold trap, and which is analyzed by FID by using gas chromatography. So the woven temperature, column temperature 0.53 mmID capillary. So by using FID, we can find whether the product is gamma valolactone or not, so by using GC. So this is general schematic reaction of the levulonic acid to gamma valolactone. So levulonic acid is a reactant here, and maybe dehydrogenation, we can get andelica lactones, and hydrogenation, it may take metallic sites. Here the hydrogenation takes place. On hydrogenation takes place, maybe 4-hydroxy pentanoic acid is formed on acidic sites, and dehydrogenation of these 4-hydroxy pentanoic acid, we can get gamma valolactone. So this is general the schematic diagram. So here what actually our work is, so in order to increase the acidic sites or metallic sites, okay, so in order to increase or enhance these sites, that means what? When the acidic sites or metallic sites may be enhanced, that is called the levulonic acid is selected for the conversion of gamma valolactone. So in order to that, we distribute that nickel catalyst in a uniform manner and with high surface area. So the main theme is in order to enhance the surface area of the nickel, so that the acidic sites or metallic sites are increases. So when the metallic sites and acidic sites are increases, the gamma valolactone selectivity is increases. When levulonic acid selectivity is increases, and that is converting into gamma valolactone. This is what actually desired product in this reaction. Okay, loading an activity that is called levulonic acid to hydrogen cyclization of a particular nickel silica catalyst. So here we just observe the capacity, that is called yield, and the percentage of the catalyst. We take an x-axis. See this, the 5% of catalyst shows that almost 70%. See that 40%, and show that almost 90%. See, already said that. So here the yielding capacities. So you know very well the yielding is completely different. All the reactants are not converting into the yielding. Okay, so the reaction conditions 50 degrees centigrade and atmospheric pressure, and levulonic acid flow rate is 1 ml per hour, and here the carrier gas is hydrogen. Very cheap and cost effective, of course. So the nickel catalyst may be spread or maybe used to market available absorbents. They are can also prepared from and market value. So apart from all these, the 30% of weight percentage of nickel silica catalyst, inexpensive and environmentally beginning catalyst for the producing of gamma lactone from hydrogen of gas acid at atmosphere. The second one is we are using two different supports for the hydrogenation of nitrobenzene. So here the nitrobenzene is converting into aniline, preparing what you can say the same activated carbon. So at the same time, we already explained the rice husk in the previous preparation methods. So here also same. The highlight of this work is highly distributed nickel nanoparticles in supported, which is extended extracted silica as well as activated carbon. Both we extracted. Prepared impregnation method. So here we are using two different methods. So wet impregnation method and reductive. Here, reductive deposition method also used to preparation of the catalyst to hydrogenation of the what you can say the hydrazine is as a reducing agent. So the highlight of the work compared to characterized by the catalyst, prepare both the impregnation and reductive deposition method. All the catalysts were almost subjected to characterize with the BET, that is called Brunner emitted LR, and scanning electron microscopy and XRD and TPR studies also. So right, yeah. So this is the preparation of activated carbon from the rice husk. So we take the simple one. 10 grams of rice husk was heated in a furniture under nitrogen at 10 degrees centigrade per minute. So here the temperature is increases slowly, that is 10 degrees centigrade per minute. Okay, up to 600 degrees centigrade for 1 hour, cooled at room temperature, hydrochloric acid, and washed without distilled water. Sorry, with the distilled water to remove the chlorine ions and pH become a neutral. The solid were dried at 110 degrees centigrade for 4 hours, and to this add here 38% of phosphoric acid and heated at 250 degrees centigrade under the airflow for 2 hours. Then the sample is subjected to heat 600 degrees centigrade under the nitrogen flow. So that sample name is called as a rice husk activated carbon. RHAC means represent activated and C represent carbon. So rice husk activated carbon. So here in order to produce more activated carbon, we go for here different from that above method, that is called 38% of phosphoric acid, that is called that means that how to prepare silica is already explained in previous work. So this is the broad preparation of the catalyst. That is, the first one is wet impregnation method, and the second one is reductive deposition method. So wet impregnation method is same as the above, The same precursor is used to, that is called nickel nitrogen 6 H2O follows and calcinated in air, reduced with the hydrogen flow for 500 degrees centigrade for 4 hours. So this is, we can call upon here only we take 5 weight percentage of nickel, that is called nickel RHAC. I means here impregnation method. At the same time, nickel RHSiO2 means nickel silica, that is called, which is prepared by impregnation method, where I represent impregnation method. Whereas coming to the most important one is reductive deposition method. Reductive deposition method. So both RHAC and silica, so treated with the 5-weight percentage of the same precursor, that is called nickel nitrogen hexahydrate. So added 1 ml, 1 molar of NaOH to get the pH value is almost 10, and add hydrazine, that is called N2H2, and allow for 1 hour. So where the hydrazine used as a reducing agent for the precursors, where the solid was washed, deionized water, and dried at 120 degrees centigrade for 12 hours. So this catalyst was at the same time here the reducing process by same process, that is called hydrogen flow at 500 degrees centigrade for 4 hours. So here why we need to use this step means in order to activate the flow, hydrogen flow at 500 degrees centigrade for 4 hours is needed. So it is 5-weight percentage nickel RHAC for R. R means that catalyst which is produced by reductive deposition method. So this is what actually the representation of how the nickel spread on the silica. This picture is clearly show that. So if the catalyst is prepared by impregnation method, so you can see that impregnation method, the nickel is distributed on this support or adsorbent, whatever it is called, to deposition. So here the nickel is distributed on the porous, what I can say, the adsorbent are distributed like this. So what is the difference between this one and this one is the surface area of the nickel, that is called the exposure or the exhibition of the nickel sites on a particular catalyst, which shows the highest surface area. Okay, so this is also you can observe the some images of the particular 4 catalysts which are prepared by the impregnation method, and the first 2 one is impregnation method, and the second 2 one is C and D. C and D was the catalyst is prepared by reductive deposition method. Okay, so among all this, so the nickel catalyst is supported on silica by using reductive deposition method is producing high surface area as both the catalyst. So this is RH, and that is called already this surface area, and pore diameter is already discussed in previous work. And whereas here and 5-weight percentage reductive deposition method. See, there is slight changes. There is no difference between these two. Slight changes. Door please. So at the same time, RHAC, that is called husk activated carbon, so which is having almost 462, and when impregnation with both impregnation method and reductive deposition method, it slowly decreases. So you know very well these two, what you can say, see here A, B, C, D, like A represent nickel, which is produced by reductive deposition method. So first two, A and B, are the catalysts of reductive deposition method, and the C, D are prepared by impregnation method. So the difference between these four is the activity of the metal. Okay, so it shows that nickel, the XRA pattern shows that. So these are the TPR results for this four catalyst, nickel, at the same time impregnation method, reductive deposition method. So the maximum T maximum is equal to almost 300 degrees centigrade. So whereas nickel silica is 450 centigrade to 610 centigrade, whereas nickel activated carbon is 374 and 375 degrees cent, like this. So this evidence that nickel silica were 250 degrees centigrade and almost able to with up to 610 degrees centigrade. Okay, this is the activity study that is called nitrobenzene is converting into nitrobenzene is converting into aniline at the same time. The nitrobenzene, we take the ultra pure H2 or maintained at with inlet flow, the same temperature, same reactor setup, but the only difference is where we take reactant as a levulinic acid, here we take it as a nitrobenzene. Okay, the same flow rate, here nitrobenzene flow rate is 1 ml per 1 hour, and the ratio is 4. So at the same time, here also we used the same woven. Here the flame ionization detector also used, but the woven and the length of the column and the thickness of the capillary column is different, quite different from the above work and this work. This is the scheme for nitrobenzene to hydration and hydrogenation and dehydration. So we can form the nitrosobenzene. On hydration, we can get phenyl hydroxylamine. On hydration and dehydration, we can get aniline. This is one of the way, direct pathway, and the indirect pathway we can get azobenzene. On azobenzene, again hydration and dehydration. Now we can get azobenzene, and this hydrogenation we can get aniline. So whatever it may be, like a direct path or maybe indirect path, here we are observing the increasing of the nickel acidity nature in order to convert the nitrobenzene into aniline. Okay, so nitrobenzene into aniline. That is the most important. So among all this, see the pattern of the four catalysts and the different temperatures. So here we just reaches up to 300 degrees centigrade, almost the catalyst may be fade out. That means what? The catalyst strength and the ability slowly decreases. Okay, at a particular temperature, it shows the highest conversion. that is called 275 degrees centigrade. So almost 250 to 275 degrees centigrade. That is called as nickel silica, that is prepared by the reductive deposition method, shows the highest deconversion rate. This is on the graph which shows the conversion and the selectivity. Okay, so and not only that, the graph shows the time factor. So time factor or in the hours, like you take that the first hour, second, and almost 10 hours. The same catalyst used for the 10 hours, that is conversion of nitrobenzene to aniline, or the previous catalyst also same. That is called levulonic acid to gamma lactone. The selectivity is same. Sometimes maybe the conversion maybe slightly decreases because of the strength. Okay. Overall description. So among all this, you can observe this. Among all this, all the catalysts like nickel silica reductive deposition method shows the good conversion, that is called nitrobenzene, as well as selected towards the aniline, which the attribute the highest distribution. So here what I'm trying to supposed to explain is rice husk is more abundance and almost rice husk is one of the most biomass, especially in Andhra Pradesh, which is which is having rich in silica and activated carbon. It is used as a good adsorbent also. So it is act as a support for the metals catalyst like nickel or chromium or etc. So the most one is the manufacturing of the silica and rice husk and rice husk hash is very cheap and low cost effective and also inexpensive. So and also environmental eco-friendly. So and also here we are using gamma lactone hydrogenation from the levulonic acid, which is under, especially levulonic acid is converting into gamma lactone. Most of the reactions are carried out in the solvent conditions, whereas here we use solvent-free conditions. So the presence of disclosed that nickel-based catalyst. So here the nickel are we are prepared in nano nature, nano size. So okay, right. Catalyst on rice husk, extracted silica, environmental free, economically and variable, inexpensive, alternative inexpensive, noble metals or catalyst in particularly hydrogenation of the levulonic acid. Okay, these are the general stability of these catalysts are very reasonably good. Okay, and the applications of a particular this. These are the I mean chromium and nickel, and here tetrahydrofuran used for the dehydration of the alcohols. Okay, okay, right. So why here the aniline that is called already conversion that levulonic acid to gamma lactone as well as nitrobenzene to aniline. So aniline is mainly utilized for MDI. So you know very well the uses of MDI. So MDI is the most versatile used in especially polymers like PU, polyurethane. So you know very well polyurethane is mainly used in shoes and etc. etc. There are number of applications are there. So in order to prepare PU, here MDI is the precursors. So in order to prepare MDI, aniline is the precursor. So in order to that preparation of aniline, nitrobenzene is the main keyword. So here the nitrobenzene is converted to aniline and aniline is converted to MDI, MDI converted to polyurethane. So before the cars development of business, okay, synthesis compound producing using aniline, including pharmaceuticals. After that, pharmaceuticals, natural compounds, items, dyes, pigments, indigos, acetone, etc., etc. Here, gamma-valolactone is one of the most used compound used to fuel chemicals. See here, gamma-valolactone is used as a biofuel. Okay, or chemicals, wide range of products manufacturing of the such as alpha methylene. Okay, so gamma-valolactone and C8 alkanes and pentanoic diols, methyl pentanoic pentanoid and dimethyl acetate and butane. So these all are fuels which we used for different purposes. Okay. Okay. So that's it. Thank you for this giving opportunity. So overall, here the theme is conveyed that is called as. See the nano nickel. So here we are preparing the nano nickel, that metal catalyst we used bio waste adsorbent. So here we are preparing adsorbent by using bio waste like a rice husk, and these are impregnated preparing a catalyst, and we are observing some applications like gamma-valolactone to levulonic acid to gamma-valolactone and nitrobenzene to NA. So that is the conclusion of the my presentation, and thank you so much for giving me this opportunity. I would like to thanks to especially Dr. K. Pratap sir, who called and who initiate this one. Thank you so much. Sir, hello.
Thank you, Anil sir. Thank you very much.
Yeah.
Thank you. Thanks to Dr. Anil Kumar sir for your wonderful lecture on nano nickel on bio applications. We are very much delighted with your lecture and your excellent presentation. Your explanation on the extraction of silica from rice husk is excellent, and our participants are very much happy with your explanation
Thank you.
on nano nickel and the porous nature of rice. The porous increased due to the nano nickel absorbance, and its explanation is very understandable, and I am very much thankful to you on behalf of the D.S.Govt Degree College for Women.
Yes. Thank you, sir. Thank you so much. I would like to convey once again my heartfelt thanks to Dr.D.KALYANI madam, principal madam of D.S.GD College for Women's, D.S.Govt Degree College for Women's, and organizing committee. Thank you so much, sir.
And the next session will be Saturday at 2 p.m. Madam? Repeat? Yes. 10th. Thank you all the participants. For this time, you can leave, and I request you all to join by 2 p.m. for the second session of this webinar. Thank you, one and all.
Hi everyone. Good afternoon to all of you. Welcome to afternoon session of the webinar. Dear students, esteemed colleagues and guests, it is both an honor and a privilege to introduce our distinguished resource person for today's webinar, Tiny Wonders, Big Future, Making and Understanding Nanomaterials, Professor N.V.S. Venugopal. Professor N. Venugopal is the head of the Department of Chemistry at the School of Science, Geetham, deemed to be University, Visakhapatnam, Andhra Pradesh, India, bringing a wealth of experience that spans over 3 decades. Professor Venugopal's illustrious academic journey commenced with his PhD in analytical chemistry from Andhra University, Visakhapatnam in 2004, following his MPhil in engineering chemistry. His commitment to excellence in education is also evident from his postgraduate diploma in higher education from the prestigious Indira Gandhi National Open University, New Delhi. Throughout his career, Professor Venugopal has held various significant administrative and academic roles, from being a lecturer to ascending to the rank of professor since 2019. His administrative acumen is demonstrated through his service as the Deputy Director of Students' Affairs and Admissions at Gautam University, among other vital roles. Professor Venugopal's contribution to the field of chemistry, especially in the realm of nanoscience, are profound. He has been recognized globally for his research excellence, receiving numerous awards, including the Professor NKM Gold Medal in 2019 and the Best Researcher Award in Nanoscience from the World Research Council in the same year. As a pioneering researcher, Professor Venugopal has guided numerous PhD and MPhil scholars, contributed significantly to science literature with over 70 publications, and led impactful projects, including the development of eco-friendly nanopesticides. His work not only showcases his expertise in analytical fertilizers, pesticides, food and drug chemistry, but also his commitment to leveraging chemistry for the betterment of society and the environment. As the chief editor of the Bulletin of Pure and Applied Sciences Chemistry and a member of various prestigious academic and scientific bodies, Professor Venugopal has significantly contributed to the global scientific community. Today, as we delve into the fascinating world of nanomaterials, we are incredibly fortunate to have Professor Venugopal lead our exploration. His insights and expertise promise to enlighten us on the potential of nanotechnology to revolutionize our future. Please join me in extending a warm welcome to Professor N.V.S. Venugopal. Venu?
Yeah. Okay. Can I start? Okay.
Yes, sure.
Yeah. Thank you, firstly, Srinivas, for your very, very affectionate my short biodata. And let us, can you make me as a host so that I can open my PPT, Srinivas?
Already you are the host, I think.
Okay.
Suresh? Suresh?
But
Okay,
share option is,
host.
yeah, 1 minute. Share option is not functioning. Just a minute. I think you need to give again. Yeah, share option. Okay. Yeah, yes. I'm trying to open it, but that share was actually completely hide. It is not activating.
Once again.
Yeah. Yeah. No, it is not opening. Otherwise, can I send you my PPT to your mail? Can you open it there? Yeah, just give me 2 seconds. Okay, Srinivas, I have sent my PPT to you. You can open. In the meantime, I'll start. Hello.
Okay, sure.
Okay, I'll start. Okay, good afternoon, my dear delegates. I think I can directly enter into my topic today. And I think in the morning session, all of you heard about so many aspects of the relevance of nanoscience and nanotechnology to the present situation, or the role of nanotechnology in agriculture. Yes, it is important for all of us to introduce the new era of modern technology, especially nanotechnology. Nowadays, picoscience is also slowly entering, and embedded systems using artificial intelligence. So there are so many what do you call new facets in technology has already encountered several, it is solving several problems or challenges to all of us. Now let us try to stick to the field of agriculture. What are the latest or otherwise sophisticated equipments that we are actually importing or we are developing in our country for the betterment of good crop yield? This is the only the final objective of either agricultural scientists or basic sciences scientists, especially relating to our chemistry part of it. How best we are trying to increase the crop yield. That is the only the major objective. So for which, how nanotechnology or nanoscience is helping us. That is what I'm going to talk for the next 35 minutes. Srinivas, can you open it?
I didn't receive any.
Yeah, I have sent to your principal mail ID.
Mail.
I have sent, no?
Okay, I will check.
Yeah. I will tell otherwise which mail ID. 1 minute. Yeah, it is ongole.jkc@gmail.com.
Yes.
Yeah.
Suresh?
Let me try. Yeah.
Yes,
Now
yes,
I
yes.
got it. Now I got it.
Sure.
Just a minute.
Is it opening?
Yeah, is it visible? Not visible, I think. Yeah. Now we can go. No problem. Yeah, sorry, dear delegate, sorry for this. Right. As I said in the beginning, the role of nanoscience and nanotechnology for best agricultural output enrichment. That is the my topic today. I'm going to explain to you. Can you go to the next slide? I think Srinivas, can you help me? Can you go to the next slide? Yes, sir. But not functioning. Some problem, I think. You can do from there, I think. Can you go to the next slide? Yes, sir. Otherwise, you can put it on slideshow. Yeah. Dear delegates, as Srinivas said that I am from Gitam University. Just for a fast 10 seconds, let me explain you about my place. So we have so many courses are running, so many programs are there in Gitam University, and we have two off campuses. One is in Hyderabad and Bangalore. Can you go to the next slide? Srinivas, it is not functioning.
The presentation is not in.
Not.
Just.
I think you have not given share option, I think.
Can you try once again?
Yeah. Can I try now? Take minute. I'll try. This share is not highlighting us. I think some problem from your side. Not highlighting. Can you see now?
Yes.
You can see? Yeah. Yeah, and these are the three off campuses, two off campuses we are having. Next slide, please. We'll go to this. The outline of my presentation, I'll be explaining about India in the world of agriculture, pressing concerns of Indian agriculture, pesticide consumption, nanotechnology in agriculture, and why nanopesticide. Next slide, please. Yeah, all of you just go through this. He is English economist Thomas Robert Malthus, and in 1798, in the year 1798 itself, he has envisaged what would be the importance of the food to the people in this particular world after 200 years later. What would be the scenario? So he is a very, very renowned demographist, and he said the population growth tends to outstrip the means of our livelihood. And he said food increases arithmetically while population increases geometrically. That means our main goal is when the population growth is definitely an indicator about the food reserves, what in our country or in the world that we are trying to preserve. There should be a linear equation between the food production and to the need. So next slide, please. Next slide. So these are facts. The present world population is touching 8.1 billion, and our Indian population is 1.44 billion. Are we really in safe mode? Is our agricultural outcome is satisfying the need of the people, their livelihood? This is another side of coin. 37 million to 118 million as per the different definitions given by some regulatory bodies, are the farmers which are really dependent on the agriculture. Agriculture is their main profession. Next slide. If you see the credits of our Indian agriculture, no doubt we are the largest producer of milk, cashew, nuts, ginger, turmeric, and black pepper, and the second largest producer of wheat, third largest of tobacco. Certain positive, records are there for our Indian agriculture. That is, we should salute our farmers. Next slide, please. Apart from these major, facets, the major, breakthroughs in our agriculture, but still there are certain spots where we need to think over it. 43% of our India's geographical area is used for agricultural activity, and we are producing 51 major crops. And it is, as I said in the beginning, it is giving food to 1 billion people. 75% people are living in rural areas and still dependent on agriculture. This is the latest scenario of our Indian agriculture. Next slide. Despite all these things, we have certain strengths, weaknesses, threats, and opportunities. If you look at the strengths here, the second one, arable land. What is arable land? Land is absolutely fit for agriculture practices. So we can easily go for even 2 or 3 crops at certain geographical areas in our country. So a wonderful arable land, that is our strength, one of the major strength. But coming to the threats, when we are talking unsustainable resource use. So there is, my dear delegates, there is one particular scheme called land reclamation scheme. And so many elders in our home may be knowing this land reclamation scheme means we should convert the unused or useless land into useful land. The phenomena in which useless land is converting into useful land, we call it as land reclamation. So we have an act called Land Reclamation Act. So called our state's agricultural ministers are occasionally saying that this academic financial year we are trying to convert a particular hectares of land into arable land, hundreds of acres of land into arable land, like that under this Land Reclamation Act. What is the threat that we are using? The agricultural lands are converting into domestic areas. Agricultural lands are converting into concrete jungles. So unsustainable resource use is a major threat that we are actually facing. Next slide, please. Next slide. Now, what are the pressing concerns of Indian agriculture? Why our Indian farmer is not happy? Why our agricultural yield is not so effective? Why it is not a perishable value we are not reaching? Means there are so many pressing concerns. Declining productivity, diminishing food grain production, of course, growing population, food security problems, rapid urbanization, rise of industrial wells, soil erosion. So the list is endless. So many pressing concerns of Indian agriculture. Despite all these pressing concerns, how we are going to get good crop yield? That is the most important aspect here. The present Central Agricultural Minister Narendra Singh Thomer very recently has submitted a report to the Prime Minister of our country, and that particular report was actually extensively discussed in the international forums. Why India, we are getting very, very moderate level of crop yield, right? So how to solve this problem? The next important topic, my topic, is the role of pesticides. My dear delegates, you all know what is a pesticide. It is a substance or mixture of substances intended for using, killing, preventing, or mitigating the target, mitigating the negative thing that spreads in our crops. That is the target, right? So there are so many different types of pesticides are there. I'm not going into those things. We have insecticides, herbicides, fungicides, rodenticides, fumigants, several type of pesticides are there. Pesticides can also be used as plant regulators, defoliants, desiccants. So there are several roles are there as far as pesticide is concerned. Next slide. Next slide. Yeah, pesticide consumption, you say 2 million tons of pesticides are utilized annually worldwide, where China is the major contributing country, followed by the USA and Argentina. However, by the year 2020, the global pesticide usage has been estimated to increase up to 3.5 million tons. So do you mean to say that 3.5 million tons of toxic substances are entering into the soil environment and later in turn into the outer environment? Means that is a question mark for us. How much of the pesticide was really used for complete 100% intended use is also a question mark from place to place, from one geographical location to another geographical location. Next slide, please. Next slide. You see the statistics here. In India, we have 80% insecticides consumption, worldwide 29.50, and herbicides, fungicides, and others. So this is a very good comparison how much pesticide that we are consuming in our country and also to the worldwide. Next slide. Next slide, please. We have pesticide management bill, that is 2020, and this pesticide management bill major objective is how best we are keeping our pesticides safe and effective pesticides are applied, and how best we are trying to reduce crop losses, how best we are trying to distribute the pest, how best the farmer is applying the pest. So these are all the various objectives, and those objectives were actually kept in pesticide management bill, that is 2020. Next one. So in this particular bill, in April 2019, the International Union of Pure and Applied Chemistry has recognized the role of nanopesticides, the role of nanotechnology, especially in agriculture. And in our particular country, in July 2019, the Department of Biotechnology has pointed out that the role of nanopesticides is to solve certain pressing concerns of Indian agriculture. So there is a very, very latest nanopesticides. Next one. Next slide. Srinivas, next slide. Okay, before going to the next slide quickly, what we have discussed about how best the population growth is affecting the food requirement and how best we are trying to produce food. What is the major agricultural yield, better agricultural yield? What are the things that we are trying to consider? And in the line of that, the role of pesticides are very important, and the handling of pesticides we converted in the form of a bill. We have a certain regulatory bodies are also there. And moving on that, the nanopesticide role is very crucial, and how best we are trying to manufacture nanopesticides, or in general pesticides means there are different forms of pesticides: liquid formulations, solid formulations, gaseous pesticides. These three levels of pesticides we are trying to implement, we are trying to apply to the various fields. Moving to the worldwide, when you talk about the annual pesticide consumption, India, we have 40 millions of kilograms that we are actually consuming. But are we really utilizing this 40 millions of kilograms of pesticides in a more effective manner? Is this really hitting the target? Is this really killing the pest? Is it really preventing the crop? Means how best we are doing. That is very, very important as far as the application part of it. Next slide, please. If you look at the per hectare consumption of pesticide, India, we are at the moderate level, 0.6. Next slide. Just for statistics sakes. Pesticide consumption in India, 65% insecticides. I think we have insecticide board is there in our country. In a particular issue, one board was kept at the national level means it is very, very important. Next one. Next slide, please. Yeah, we are having right now 234 pesticide registers in India. Out of these, 4 are WHO class of level A pesticides, 15 are WHO class of level B pesticides, 76 are class 2 pesticides. The World Health Organization has categorically divided pesticides into several categories: level 1, level 2, level 3, like that. So level 1 pesticides are the most toxic. Its handling, we have to follow the guidelines of the regulatory body. Its distribution, we have to follow the guidelines of regulatory body, like that. So if you compare with the crop-wise consumption, just for our understanding sake, these are the cotton, rice, soya bean, how we are trying to utilize pesticides for different crops, how best we are actually consuming it. Means this particular slide subtly indicates that pesticides are very much required if you want to expect a good crop yield. Now we have certain regulations, Insecticide Act, so many acts are there. So these are all regulatory bodies and the guidelines for these particular regulations we are following. Next slide, please. Next slide. Yeah. What are the benefits of pesticides? If a layman should understand, means 4 important benefits. One is food preservation, crop protection, material preservation, disease control. So these are the 4 different benefits, large scale benefits are there, why pesticides are necessary for us. Global input over 4.5 million tons per year. This is how we are actually producing as compared to the production value per year, involving thousands of toxic compounds, saving about 30% loss of the total production. So my dear delegates, so far you have understood what is the relevance of pesticides for the betterment of agricultural good crop yield, and what is the relevance of regulatory bodies, why regulatory bodies are important, why the pesticide management bill is important. So these things are there. And before that, you understood about the pressing concerns of Indian agriculture. Now, the most dangerous particular state that we have reached is more than 70% of pesticides flow into the environment and residue in plant products and in process of application. I am very sorry to say this statement after lunch. You have taken certain food. Do you mean to say that that food contains pesticide residue? Means who knows, it may contain or may not contain. But this is the high level of what you call time that all the scientists, agricultural scientists, they are now doing extensive emerging trend in pesticide research to solve this 70% flow into the environment and also into the food content. Let's see how we are going to solve that. Next slide, please. Now, a technology is needed to solve this particular dangerous problem. What is the technology? We are moving to modern technology, that is nanotechnology. Your webinar title itself is the role of nanoscience and nanotechnology. You understood so far, small is beautiful. If the particle size is reduced, it is giving you extensive and very, very enhancement in properties. Same principle was adopted in producing nanopesticides. And these are the 3 important scientists who are the game changer, key persons as far as nanoscience and nanotechnology is concerned. Next slide, please. Next slide. Next slide. Yeah. What are the drivers for nanotechnology in agriculture? Not only in our country, in the world, these are only the drivers that is focusing on reducing impact to the environment and human health. Farmer should be safe, your crop should be safe, soil environment should be safe, environment should be safe. These are actually the key points for the introduction of nanotechnology in agriculture. Next slide, please. Next slide, please. And these are the applications of nanotechnology. I'm not going into that. Next slide, please. Yeah. Nanotechnology in agriculture, now protection, that is my research area, my dear delegates. role of nano pesticide here. Now, if I introduce pesticide here, my plant health should be safe. You see, for human beings, if any health problem is there, we have Apollo, Medicover, so many hospitals are there. If the same health problem for the plant, what is that Apollo? That Apollo is nano pesticide. That Apollo is the latest pesticides that are available in society, right? So for plant health management, nano pesticide is the only the better option, or perhaps the best option we can see. Not only nanotechnology is utilized for the development of nanopesticides, several other segments are there in agriculture. I'm not going into that. Fertilizers, sensors, etc. Let us stick to nanopesticide. Next slide, please. Next slide, please. Yeah. If I develop nanopesticide, what would be the market share? That means the government, Indian government, is also getting a lot of profit by selling nanopesticides that are developed in our country. So, my dear delegates, you please kindly go through these. These are all nanopesticides which are available, approved, regulated, that is available in the market. These are all nanopesticides available in the market. And what is the advantage here? If you use commercial pesticide, for example, 10 acres of agricultural land, if you are using 3 kilograms of pesticide, you can use 700 grams. I repeat, 700 grams of nanopesticide. That is more than sufficient. Now, how nanopesticide work out means as simple as nanomaterial. Now, how do properties change at nano level? You already understood. The physics fraternity will say about this. Increase in surface area to volume ratio. Yes, here also it is going to happen. Quantum mechanical effect, same principle we will adopt. Electromagnetic forces and their dominance, same thing. And random or Brownian motion. So these are the 4 key aspects how you are going to understand nanomaterial. In the same manner, you are trying to understand for nanopesticide as well. Now, the best, thing that we are expecting from nanopesticide is the efficacy. Increase efficiency of resource utilization, minimize waste production. Now, if I use commercial pesticide, if 35% is being wasted, if I use nanopesticide, only 15 to 20% is only wasted. So that is the main, goal that we have kept in developing nanopesticides. Next one. Next slide, please. Now, what is nanopesticide? There is a clear-cut definition given by the regulatory bodies. That is plant production products which are developed using nanotechnology to enhance the efficacy and reduce the environmental load of pesticide. I think all the developed countries in the world, they are concentrating on the reduction to introduce the pesticide into the environment. The first nanopesticide in 2011, that is AGS silver, that is AGS 20, was actually developed. Next one. Next slide, please. Now, why nanopesticide? I told you, for better efficacy, minimizing the environmental load. And the third important thing is, if the utilization is also very, very less, be it in terms of quantity or if in terms of application even. If 3 times the farmer is applying, if you use nanopesticide 1 time or 2 times, more than sufficient. Such positive results are also available at the present times. Next one. Next slide, please. Next slide. Next slide, please. Next slide. I'll go to my work. Next slide. Srinivas, next slide. Yeah. What are the objectives of previous slide. What are the objectives of nanopesticides? Means there are so many agencies in our country, they are trying to develop nanopesticides. These are the 4 objectives. Control release, target delivery, efficacy, duration, lower toxicity. In Geetham University, in my laboratory, the second one, control release, we have given the major thrust area. We have developed a few nanopesticides based on this particular objective, control release. Next slide, please. Next slide. Now, what are the advantages? Good penetration strength, good wettability, high dispersive nature, good surface to volume ratio, better bioefficacy results, less time and low economic. And here I would like to mention one important point here. In the very recently, a industry called Indophil, which is largest manufacturing mango jab, which is a fungicide in the world, which is in Maharashtra. They came all the way from their place to Geetham University, and they have given me a project for developing nano mango gel. So we have given 4 formulations to them. Out of 4, 2 were successful. They have cleared the pilot, studies also. Hopefully in 2025, that nano mango gel will enter into the market. So from that, they are going to get good extent of profits also. So that is also another advantage. Now coming back to, I told you control release, I am trying to encapsulate my pesticide molecule in a polymer capsule like this. So nano encapsulation was the successful phenomena, not only in our country, in the world itself. Everyone now, they are trying to encapsulate the active pesticide ingredient in a polymer. Next one. Next slide, please. Next slide. Yeah. So these are the pesticides we have developed in our laboratory. Carbendazim, mango jab, I told you, we got a lab to land credit from this particular, fungicide. Tricyclozole, acephate, already so many different types of nano acephates are available in the market. And catap hydrochloride, acetamiprid, this is the recent one we have developed in our laboratory. For the aspirants who wants to do research in this field, very simple. We are taking pesticide molecule, we are trying to encapsulate in a polymeric film, and this particular capsule will enter into the agricultural field, and it hits the target. Once it hits the target, first the encapsulated layer undergoes dissolution, and slowly in a controlled released manner, the active ingredient will hit the target. That is the encapsulated pesticide and its release. The controlled release, because of this controlled release, we can also have many enhanced properties. Now, how to do that? First of all, you should confirm your pesticide is in nano level. Now, how to confirm a particular material in nano level? We need to undergo a little bit of trial and error method, and later we have to do characterization. So first of all, you should confirm the particle size should be in 1 to 100 nanometers, for which you should certainly take the dynamic light scattering, scanning electron, TEM, transmission electron microscope, and FTIR. So these are certain sophisticated analytical instrumentation is necessary to affirm your particular particle is a nanopesticide. Next slide, please. Next slide. Yeah, just for your understanding sake, very recently we have developed this mango jab. This is the commercial mango jab where the particle size will be around thousands of micrometers. I think 26,000 of micrometers is approximately the particle size of mango jab, whereas encapsulated mango jab will be having 40 to 60 nanometers. 40 to 60 nanometers. This is the encapsulated mango jab. It is already in the patent process, and for further details I cannot disclose at this particular point of time. But several positive results I'm going to show in the next slide. Next slide, please. Yeah. First of all, if you are trying to do the antifungal assay, you see at the bottom, if I take 15 ppm concentration, the commercial pesticide has killed 1.6 millimeters of zone of inhibition. Whereas if you use nano pesticide, it is 2.4, much more increase, much more zone of inhibition I observed, 2.4. Just it is only the one that we can disclose, but we have increased the concentration. Can you go back to the slide, Srinivas Garu? Can you go back? Can you go back? Yeah. If you increase the concentration, and you can also study, there should be increase in zone of inhibition. at different temperatures, at different soil environments, and at different targets. Just for your understanding sake, I have placed here, we have tried with aspergillus niger. We got a very good, successful results are there. That's the reason this technology was actually handed over by that particular Indophil company. Now it is in the final stage of its completion. Hopefully next year it is going to enter into the market. Like this, many companies, Bayer's company, so many companies, now all agro industries are trying to have their own setup to develop nano pesticides. To sum up, a better alternative to conventional pesticide is nanopesticide. Nanopesticide was formulated using polypropylene glycol and polyethylene glycol, and almost all companies are using. This is the cheapest, low cost and eco-friendly polymeric film everyone is using for characterization. As I said, you require different analytical sophisticated instrumentation is necessary for you. Next slide, please. Next slide. And these are all my PhD students who worked in this, especially nano pesticide. The first 6 worked in nano pesticides. And these are my collaborators. This is the Indophil company I mentioned. And these are the game changers in our country. Hopefully 2025 onwards, this is going to conquer the pesticide industry. And this is one more absolute, which is in Noida. And we have tied up with, and I'm the, is a very good collaborator to me, and have done several UGC projects, and this is also my strength. Thank you very much. That's all from my side, Srinivas.
If anyone wants to interact, Venugopal can interact. Otherwise, we will go.
Okay, as there are no questions, okay, Srinivas, I am very thankful to you, Government Degree College for Women, Ongole, especially my learned friend, Dr. Srinivas Reddy. I appreciate his interest always towards student community and also faculty. And thank you, Srinivas. Thank you, all organizers. Thank you. If you have any doubts regarding this, you are welcome to send me a mail, or you can also contact me. I will certainly share my thoughts. Thank you. Thank you, Srinivas.
I greatly appreciate Professor M.S. Venugopal. Your presentation today demonstrated nanophysics. Here you are shaping science and teaching the next generation of researchers. Your presence today adds an emotional depth to our gratitude for your excellent contribution to this webinar. Professor Venugopal, your rise from academia to chemistry luminary is an inspirational to pursue knowledge. Your insights today have expanded our minds and intellectual curiosity. On behalf of everyone here, we appreciate your work and your insightful speech. We carry the profound implications of the tiny wonders that indeed predict a big future. We appreciate your guidance on this fascinating exploration by IQAC. Thank you, Venugopal.
Thank you, all of you. Thank you.
Sir, Prasad sir.
Yeah, madam. Good afternoon.
Good afternoon, sir. Now I am welcoming Dr. DNVKV Prasad Garu, Principal Scientist, that is related to Soil Science, Nanotechnology Laboratory, Regional Agriculture Research Station, NG Ranga Agricultural University, Tirupati. He completed his postdoctoral degree in Australia, South University, Australia, Ongole, and he published 220 national papers and international international publications at 6, and he completed his ERF, that is Endeavour Research Fellow in Australia, and his research interests are that is soil technology development, soil science, development of agriculturally beneficial nanoscale materials, and study of their behavior in agro ecosystem, including animal and human health. And I am welcoming Dr. Prasad Garu to deliver his valuable speech to our students and for our faculty members.
Yes.
Good afternoon, all. First of all, I would like to thank the organizers, particularly Dr. P. Indira Madam, for giving me this opportunity to interact with you this day. Madam, are you able to hear me?
Yes, sir.
Hello?
Yes, sir.
Yeah. Are you able to see the slide?
Slide is not appearing. That is, your face is visible.
PPT share there, sir. Sir, please share the PPT, sir.
Madam, now it is visible?
No, sir.
Yeah, but it is not in the slide mode. Yeah.
Sir, press the F5, sir. F5.
Fifth icon. That is sound speakers. Yeah. No. No, nothing was found. Icon is there up, just like up arrow like this, but when you, yeah, I got several options. No, Bluetooth is there. No, the slideshow, it is not showing. Yes. Is it okay, sir, now? Yeah, open the PowerPoint. Yes. We have opened the slideshow also. Yeah. Yes, sir. That's what we are trying. Actually, it was there in PPT. It was there, and we are trying to. Yeah. Tell me. Which one? No. So actually, in our system, it is showing the slide mode, but I do not know. Up arrow. Yes, Windows open, sir. Yeah. Yes, sir. Yeah, I think it is. It should come. Yes, sir, it should come. Now it is sharing my. Is it okay, sir? Yes, sir. Yes, sir. So sorry for the delay. Yeah. Now also. Yeah. Is it fine, sir, now? Sir, FI it is. Yes, sir, I have gone. Yeah. Now it is okay, sir. I have gone for slideshow. Put it all away, problem. 1 second, sir. 1 second. Sir, now is it visible, sir, in slideshow? No, sir, it is. Yeah. Yes, sir. Windows, we went to enter screen, yeah. No. Slideshow. Now, is it okay, sir? Is it okay, sir? Is it okay, sir,
Okay.
now? Yeah, thank you.
Okay, sir.
Thank you. Thank you, thank you. Sorry for the disturbance. First of all, I would like to thank the organizers, particularly Dr. Indra Madam, for giving me this opportunity to interact with you today. And I should thank my predecessor and my previous speaker, Dr. Venugopal sir, who made my job very easy to introduce the concept of nanotechnology and also its applications in agriculture. Yeah, so basically I'm a physicist, but I have been working with agriculture university since 23 years. And we have been doing some stuff in nanotechnology and its applications in agriculture, particularly to enhance the productivity. So to start my lecture, I think it is wise to give a certain introduction to nanotechnology. But actually, I think my previous speakers already covered a lot. Still, I dare to give certain introduction about the nanotechnology, and afterwards, I'm going to give certain details about the kind of works that are being carried out in our laboratory and the salient results and the future lines ahead. Yeah, all of you know that this nano means very small. It's very small at the matter scale. It's not an individual atom or molecule. Our nanometer means it measures a group of atoms or molecules put together, typically in the range of 10 to the power of -9 meters. So that's what we call it as a nanoscale, and that particular material is said to be a nanoscale material. And the Richard Feynman, everybody knows that he would be considered as the father of nanotechnology. So he envisioned this concept in the 1959 itself, that in future there is every possibility of playing with the atoms, and the atoms could be arranged the way we wanted. And now finally, then come to the definition of nanotechnology, though it is still not completed, but as on today, this is most agreed definition of the nanotechnology. So it is nothing but engineering the atoms at nanoscale, that is 1 to 99 nanometers, with quantum confinement. Why we should talk about the nano, or why should we go for the nanotechnology means, so at nanoscale, materials will have high surface to volume ratio, means their surface area increases to several folds for the given volume. Further, there is an enhanced chemical reactivity, so they are chemically highly active, and extended periods of bioavailability. This particular property is much more useful in the biological systems when you are going to apply nanometers in the biological system. So extended periods of bioavailability plays an important role to reduce the doses of application. And finally, all these nanometers are in the quantum design. So I'm going to give examples to each and one of these properties in detail. Yeah. So let us consider a boy is running towards a wall, big wall, whose energy is not sufficient to cross the wall. So eventually what you are going to observe, simply the boy is going to hit the wall and fell. So that's what we call it as the classical mechanical effects, or means the material which follows this classical mechanics obey this principle, particularly Newtonian mechanics. So simply the boy doesn't possess any sufficient energy to cross this barrier. That's why he will fall down. Suppose if the boy acquires certain quantum effects, so eventually you are going to find the same boy on the other side of the wall. So somehow you could able to manage to cross the wall. That means once the boy is going to cross the wall, so it is not a normal boy, so it is said to be a super boy or a ghost, you can say that. So these kind of properties are exhibited by the nanomaterials. So nanomaterials are not ordinary materials. Once they cut down to the nanoscale, they acquire certain special properties so that they're going to exhibit novel and unexpected properties. So the second one is, so for a given volume, the surface area is so the 7 emotions, this some sucrose kind of thing. That substance, volume of substance is going to area of at least that is maybe equivalent to 1 football ground. That means, so if you are going to apply these nanoscale materials in biological systems like agriculture or medicine, so small volumes are enough for a given land. Very very small substances are enough to cut. You would find for a given material at the bulk scale means ordinary materials possess 10% of atoms on the surface. As you know that the reactivity. So unlike in the bulk material, at nanoscale materials, they are going to possess 50% of the atoms on the surface. So that means a minimum of 5 times the nanoscale. So in that way, the chemical reactivity of the nanomaterials are increased by several folds. So now we are talking about the nanotechnology, and already we have talked about several technologies before also, nanotechnology also. Suppose if you are going to ignore the nanotechnology this time, let us see, is there any other technology available beyond nano? So we all know this time, mass, and length are the fundamental physical quantities. So as far as my knowledge is concerned, the time is up to 10 to the power minus 80 seconds we could able to measure nowadays by using this latest technologies. That is the time taken by an accelerated electron, the cesium atom, to come down to the ground state. That is 10 to the power minus 18 seconds. So that is taken as the standard of the time. That we know that is 10 to the power minus 8 seconds. Then coming to the mass, we could able to measure up to Zepto level. That means 10 to the power minus 21 ml. So some gas was measured up to the 10 to the power minus 21 ml. But as far as length is concerned, this is nano is the 10 to the power, that is nano means 10 to the power minus 9 meters. Is the last scale available for anybody if they want to work with the materials. So what is there beyond 10 to the power minus 9 means there are individual atoms and molecules. So working with individual atoms and molecules are never be called as working with the material. So if you want to work with the materials, this is the last scale available. Therefore, the nanotechnology is the last technology available to the mankind if they want to work with the materials, not individual atoms or molecules. So another advantage of adopting nanotechnology is that usually we can see development of a theory, and then that is going to be a science, and then some science is going to be converted into the technology, and only 4% of the technologies are going to be converted as products. So whatever we have been witnessing the products in the market nowadays, those are the entire 4% of the entire technology is developed, and a portion of the science is converted into the technology. So this is what we followed. Actually, we have so much of science in the books, but not every science is not going to be converted into technology. Not every technology is going to be converted into the products. But if you are going to develop the nanoscience, so nanotechnology is automatically developed, because if you want to develop the nanoscience, you have to use the nanotechnology and vice versa. So there is no time gap between the development of the science and technology at nanoscale. So they are going to develop both hand in hand, and over and above, more number of products are possible by adopting the nanotechnologies. So that means the transitioning from science to products is very, very high at nanoscale. That means we are going to witness numerous products in the coming days with the application of the nanotechnologies. Therefore, it is possible in all the sectors, including agriculture. So here I want to present some of the particles that are being prepared in our laboratory. First, we adopted the biosynthesis method because people are worried about the toxicity of the nanoparticles, and most of the cases it was reported that nanoparticles are causing toxic effects on the plants. So keeping in that view, we have by synthesizing the nanoparticles by using the plant leaf extracts. So these are the silver nanoparticles. You know that silver is a good antimicrobial agent. So we started synthesizing the silver nanoparticles using the oak leaf extract, and we have again started synthesizing the phosphorus nanoparticles using the stevia leaf extract. But we have changed the sources. You could see the change in the shape and size of the nanoparticles. So there are several protocols that are being developed and also being developing now also to develop a variety of nanoparticles by varying the sources, by varying the protocols, by varying the plant starts also. So this is one of the best examples that how a same product or same phosphorus material is going to be varied at a scale if you are going to change the source of the phosphorus. So here, if you can see in the upper side, so I have used the Jordan extract as the source of the phosphate. I have not changed the plant extract, that is the same stevia leaf extract. So I could able to end up with this circular shaped nanoparticles with core shell in it, solid nanoparticles. So that means there are so much of variations, or so many variations you could encounter when you're going to simply change the protocols or kind of sources. So it's a vast science. So likewise, these are the chitosan nanoparticles synthesized. This chitosan, you know that this is a biopolymer and it will be utilized to host a number of chemical ions. So that's why we prepared this chitosan nanoparticles, and we have been working seriously on this particles application in agriculture to carry very important chemicals, and as Professor Venugopal sir told that, so pesticides or fungicides, everything is going to be loaded into this chitosan, this nanochitosan. And these are some of the products that are being prepared for laboratory: nano zinc, calcium, silica, and prepared nanochitosan, nano mancozeb also. The mancozeb was encapsulated with the nanochitosan and also imidacloprid. This is a insecticide. So you can see the figures. They're very clear that they're nano and more effective. We evaluate the efficacy also. And this is one of the important research now also in progress in our laboratory. So far you might have heard about the nano products and nano fertilizers for foliar applications only, because they are going to applicable only on the standing crop and not to the soil. But there are several advantages when you are going to apply fertilizer to the soil. Particularly, it could become the food for the microbes, so that the microbial population is going to be enhanced, and so on and so forth. So that's why in that respect, we tried to develop a nano fertilizer for soil application. So for that, we have taken the biochar. You know that biochar is a coal, specially made coal. So we made that coal into the nano. So call it as nano biochar, and we could able to load the nitrogen and potassium ions onto it, so that finally we could able to develop nano biochar based nitrogen and nano biochar based potassium for the soil application. I think perhaps this is the first of its kind of work across the globe. Maybe I can say all these methods are patented, and once it is going to be released, this is the first of its kind of fertilizer for soil application at nano scale. So you know that already Professor Venugopal has given extensive introduction to the current scenario of Indian agriculture and also global agriculture, and what is the need for doing research in agriculture to feed the ever-increasing population. So one of the UN survey also potentially revealed that agricultural productivity enhancement is the second most critical area. First would be the water, and the next will be the how best are you going to increase the agricultural productivity enhancement. That means, so you need to increase the productivity levels of the present existing crops, because we don't create any extra soil or any kind of thing. with the existing soil and with the existing resources, with the existing water. So we need to increase the productivity levels of the agriculture by using certain technologies. So in that respect, nanotechnologies are much more useful. I'm going to tell so how they are useful in my next slides. So this is crop production. So application of nanoscale zinc oxide to groundnut. So all of you know that zinc is one of the important elements for not only for the plants, all the biological systems, including humans. So inadequate zinc nutrition leads to several ill effects, particularly health effects and also short stature. That means people become very short because of the deficiency of the zinc. The same thing is going to happen in the plants also. Moreover, it is going to affect, that means negatively affects that productivity of the plant. So that's why we have first focused on the supply of this zinc through nanoscale material called nano zinc oxide. So this is the nano zinc oxide prepared in our laboratory. And as I told that because at nanoscale, the metals are having enhanced chemical reactivity, so that the doses are going to be reduced drastically. So usually we recommend to the farmers at the rate of 2 grams per liter, that is 30 grams in 15 liters of zinc sulfate to correct the zinc deficiency on any standing crop. That is a regular recommendation. But what we did is, so because we have the nanoscale zinc oxide, and we have that theoretically it is going to be having more chemical reactivity. So that's why we have reduced the dose to the 15 times. That means we have mixed only 2 grams of nano zinc oxide in 15 liters. And we checked it with the regular recommendation of zinc sulfate, that is 30 grams in 15 liters. You could see the result. So if you look at the plants, so the plant which received nano zinc oxide at the rate of 2 grams per 15 liters is looks very healthy and very strong. And the left hand side, so that is the plant received zinc sulfate at the rate of 30 grams per 15 liters. Means the chemical quantity received by the plant is higher, but the effectiveness is very low when compared with the nano. Clearly you could see this. Yeah, these are the 5 plants. In the 5 plants also you can see the plants looks very healthy and very strong, and the yield is more with the application of nanoscale zinc oxide at the rate of only 2 grams of 15 means we have reduced the usage of chemical to the 15 times. And one more interesting thing is that, so as Professor Venugopal sir told in the last half an hour, I think use of pesticides and fungicides is indiscriminate. I think it is causing a lot of environmental hazards both to the environment as well as the humans. But when you are going to apply this nanoscale materials of this zinc or calcium kind of thing, we are not supplying any kind of pesticide or fungicide during the crop growth period. This is another important aspect when you are going to apply the nanomaterials on the crop. So not only we are providing the nutrition, but also we are providing self-protection, or we are enhancing the self-protection mechanism of the plant by enhancing its defensive mechanism against the incident pests and diseases. So that means no disease was observed when you are going to apply the nano zinc oxide. It is another important thing that we could able to reduce the usage of the pesticides or fungicides when you are going to apply nanoscale materials as the nutrients. Yeah, these are the results. Almost 29% yield was enhanced with the reduced application of, that means 15 times reduced application of the zinc. So this is another important case study we have carried out in our laboratory. So usually we know that calcium is one of the important elements both to plants and to the humans. But the one thing, the problem with the plant nutrition, particularly with regard to the calcium, is that so calcium is highly immobile through the phloem. Means, so when you are going to apply calcium through the foliar application, means spraying on the plant, it won't reach the root because the phloem transport is highly restricted, and calcium won't transport through the phloem. But just as I told, I have shown the boy actually in my previous slides. Even though the boy is having the not having the sufficient energy, he could able to cross the barrier because he acquires the quantum effects. So as theory says that whenever a material is cut down to the nanoscale, automatically it is going to acquire the quantum effects. If such kind of effect is there, definitely this calcium should pass through the phloem. So that is the experiment, and we conducted, and these are the calcium oxide nanoparticles. And the experiment is showing clearly the transport of the calcium. That means the left side is the calcium deficient plant. So means we have sprayed calcium nitrate, that is a bulk material, so which is not passing through the phloem. But on the right hand side, we applied the nanocalcium. So because of the acquired quantum properties, what we can say, we have been anticipating, but actually we need to prove all these things, means it acquired the quantum effects. That is another topic of research. But in general, in comparison, when you are applying the calcium nitrate on the left side and applying the calcium oxide of nano right side, so you could see the correction of the deficiency of the calcium by, I think roots are very white, means it is a symptom of correcting the calcium deficiency. Whereas in the left hand side, so roots are still black, means they are deficient in the calcium. So this is the first report in the literature, and we have proven that at nanoscale, calcium could thoroughly passing through the phloem. And likewise, we have been conducting different experiments on different crops using different nanoscale materials. And every time we used to get a very good yield enhancement. Particularly, I'm talking about the yield. Besides yield, there are several advantages like reduction in the pesticide and fungicide uses, or no pesticide and fungicide uses, and biofortification of the nutrients. All these things are there. Just I'm focusing on the productivity enhancement. That's why I have given this slide. So there is a minimum of 10% to almost 22% of 8% to 22% of yield enhancement is there across the crops, across the nanoscale materials. So that means beyond doubt, so nanoscale materials are going to increase the productivity levels of the agricultural crops with a reduced dose of application. You can see the doses of application, 2 grams or 15 liters, 2 grams in 10 liters, 2 grams in 5 liters, and so on and so forth. So that means relatively lesser doses, and if you want to give these materials to the farmer level, I think we need to follow these guidelines. We need to first test the biosafety that we have been doing now, and the licensing for commercialization and upscaling. So once we are going to pass through these steps, so all these materials are available to the farming community. Then this is my interesting part. Maybe the audience most of the audience are students and even faculty members also. But I want to give a stress on this case study because though it is not directly related to the agriculture, it is certainly going to give an overall idea about our health and our food consumption. So all of you know this MSG, this monosodium glutamate, Ajinomoto you can say. This is a tasting salt we have been calling. This is being used in almost all the fast foods, and actually it is a slow poison. It is a slow poison. Having said this, actually, we thought that why we have initiated this kind of arguments, we thought that if nanomaterials are going to exhibit a novel properties, so is there any possibility of ameliorating the ill effects caused by the consumption of the monosodium glutamate? So for that, we have used the nanoscale zinc oxide particles because zinc is considered to be one of the healthier element for all the biological systems, including the human health. And second one is that it is the free radical quencher. It is a good free radical quencher. That means it is going to quench the free radicals that is going to cause the damage to the cells. So in that respect, why don't we use this zinc oxide to ameliorate this ill effects caused by this consumption of the MSG? Yeah, you know this. All these foods, all the fast foods, MSG. And one of the biggest symptom by consuming this MSG is that obesity. Those who are consuming fast food regularly, definitely they're prone to obesity. Okay, yeah. So MSG is not a nutrient, vitamin, or a mineral, and has not any health benefit, but it is a slow poison. You know that. You know the benefits of the zinc. Then we have funded the experiment by dividing the rats into 4 groups. One is the control group, the thing was fed. Second one is monosodium glutamate fed. Third one is the only zinc oxide particles fed. And fourth one is the monosodium glutamate plus zinc oxide. Both were given. So we have checked these certain parameters. I think we have checked so many parameters, but I want to give only a certain information which is interested to the audience. Body weight, hematological, biochemical, oxidative damage, gross pathology, histopathology. If you look at the body weight, the rat which consumed the MSG alone had a significant increment in the body weight. You can see this graph. Whereas the rat which consumed the nanoscale zinc oxide particles alone is on par with the control. There is no change. Means consuming the zinc oxide nanoparticles won't harm anybody. That is the first one. The second one is that if you want to consume MSG with the zinc oxide nanoparticles, there is no significant difference in the body weight. That means safely you can consume MSG along with the zinc oxide nanoparticles. That means zinc oxide nanoparticles is going to nullify the ill effects caused by the consumption of the MSG. This is very clear. But if you are going to consume MSG alone, that means your fast foods are containing MSG, then certainly over a period of time, so definitely your body weight is going to increase significantly. And the hemoglobin content, you could see the hemoglobin content is significantly decreased with the consumption of the MSG. But whereas in all other groups, they are almost on par. So cholesterol increases significantly with the consumption of the MSG. And the remaining groups almost, there is a slight increment in the MSG plus zinc oxide nanoparticles consumed rat, but the increment is non-significant. So that means safely you can consume the MSG along with the zinc oxide nanoparticles. Likewise, we have tested so many things, and in every parameter, you could see the significant increment in the particular parameter with the consumption of the MSG. So creatine level, you could see the creatine level. Creatine levels are increased to the very, very high levels with the consumption of the MSG, whereas there is no significant difference in the creatine levels, both in the control as well as the rat which was consumed only zinc oxide nanoparticles and also MSG plus zinc oxide nanoparticles. So likewise, liver also going to be damaged, and SOD liver also, and the catalase activity decreases, liver activity is severely damaged by the consumption of the MSG. So therefore, I think I request you have to seriously consider this study before you are consuming MSG or fast foods. And all of you know this gentleman is India's future is in nanotechnology. So that I think we all should work in the nanotechnologies in different sectors to bring pride to the nation. Thank you.
Thank you very much, sir. Your presentation is valuable and very much interesting. Your interrelate the concept of classical and quantum mechanics is very interesting. And you explained nanotechnology in agriculture and how the quantities of chemicals reduced with the nanomaterials. Your entire topic explained about how to increase the yield with the nanomaterials and for good health. Thank you very much, sir. Thank you.
Thank you, madam. Thank you, madam. Any questions? I think I'm ready to answer.
Sir, mere.
Any questions? Yeah. I think if there are no questions, I think I should thank everybody.
Good evening,
The organizers.
all participants.
Yeah. Please.
Is there any queries? Sir will answer you. Please. Any questions? మన వీడియో ఆన్ చేయాలా? లేదు.
Yes, sir. Yes. Yeah, my video is on, sir. actually.
So may I proceed? Respected all participants, we are going to conclude the webinar in few minutes. The webinar topic, Tiny Wonders, Big Future, Understanding the Nanomaterials. You know that nanomaterials, nanoscience, nanotechnology is a multidisciplinary science. In fact, nanoparticle synthesis and their applications changed the present scenario in scientific fields. There are different applications are there of the nanomaterials like nanomedicine, targeting drug delivery, MRI imaging, nanoagriculture, nanophysics. There are different types of applications are there. The size of the nanoparticle is the main cause for the development of the science. As we know that the nano is equal to 10 to the power of minus 9 meters. See, a nanoparticle, we have to consider the size of a nanoparticle from the particles having the size from 1 to 100 nanometers. Understanding nano size is very important. The main elements in the nanochemistry like silver, zinc, potassium, cobalt, phosphorus, etc. can form the different nanoparticles. The iron oxide nanoparticles plays a vital role in the synthesis of magnetic nanoparticles. So like this, we have to develop the nanoscience in the forthcoming days. I express my deepest gratitude to all the participants, speakers, and the organizers of this webinar, especially our organizing committee and our principal madam, Dr.D.KALYANI garu, who has given the great webinar. Throughout the webinar, we were very much enlightened. I thought that the aim of the webinar was fulfilled. The remarkable advancements to pave the way to transform interactions across the different fields identified. So, coming to the entire webinar scenario, in the beginning lecture, Dr. J.N. Kiran, Professor, VFSTR, delivered on nanomaterials from known to unknown. As one, really, it was a great theme that nanomaterials exist from the very ancient days. Example, the Greeks painting on clay pots or jugs by heating the clay material at certain temperature. As we know, every nanoscience student must read this topic in the beginning of learning nanotechnology. Dr. J.N. Kiran explained all fields of nanomaterials, preparations of magnetic nanomaterials, and the electric properties, magnetic properties. We discussed the different various fields of nanomaterial, various fields and the properties of nanomaterials. We know that after after Richard Feynman's statement in 1950s, a French physicist said that there is a plenty of space at the bottom of the atom. It was the beginning in the present century to enhance the all fields of nanoscience. In the second lecture, Dr. T. Anil Kumar, who is an assistant professor at Krishna University, delivered his lecture on catalytic activity of nanonickel as an adsorbent. The nanonickel acted as a good adsorbent on the metals, and he delivered the catalytic activity of nanonickel and the property of nanonickel as an adsorbent. And he explained different issues there. In the third lecture, Professor N.V.S. Venugopal, School of Science, Geetham University, he discussed the various nanopesticides. He discussed the nanopesticides, and he has given a lot of information on the activities of pesticides, the benefits of pesticides, and how the pesticide residues in our foods, how they are damaging our health, and what the measures to be taken, and what will be the government, how the government should have to institute different nano pesticide protecting organizations. And he discussed nanotechnology in agriculture, nanotechnology and nanoscience, the crop protection, how to protect the crop, plant health management. By using the nanopesticides, how we can protect the plant from the diseases. We discussed for example, he told us to take 3 kgs of nanopesticide. Instead of 3 kgs, we have to take only 700 grams nanopesticide, which efficiently works in certain area of the crop, and minimizing the diseases, how he has explained. In the fourth lecture, Dr. T.N.K. Prasad, who is a scientist, and he explained the T.N.K. Prasad, who is a scientist, he explained nanopesticides, chemical activities, bioavailability, and chemical mechanics, the size of the particle, how affects the agriculture material, and the properties of the nanomaterials he explained. Soil applications at the nanoscale. He also explained the soil applications at nanoscale. And he has delivered how the nano nitrogen and nano phosphorus works in the plants. In all the way, after the completion of 4 lectures, we are very much enlightened in the nanotechnology. And I am happy to disclose these few words regarding the closing words to this webinar. And I am very much thankful to the committee, participants, our college staff from all the departments, and our organizing committee, Dr. Srinivas Reddy Garu, Madam, and with their all support, we have completed this webinar. So I am closing my few words, with this regarding the closing words of this webinar. Thank you, one and all.
Good evening, everyone. I am Mr. B. Srinivas Rao, lecturer in Department of Physics, D.S.Govt. College for Women, Ongole. I am giving overall vote of thanks about this webinar. On behalf of the Department of Physics and Chemistry, D.S.Govt. College for Women, Ongole, extend a warm vote of thanks to everyone who contributed to making today's physics webinar a resounding success. We would like to express our gratitude to Commissioner of College Education, Mangalagiri, and Dr. D.KALYANI, Principal, D.S.Govt. College for Women, Ongole, for their generous support, without which this webinar would not have been possible. Firstly, our sincere gratitude goes to our distinguished speakers, Dr. J.M. Kiran, Professor, VFSTR, deemed to be University, Guntur. Second, Professor N.V.S. Venugopal, Head Department of Chemistry, School of Science, Githam, deemed to be University, Visakhapatnam. Third, Dr. T. Anil Kumar, Assistant Professor, Krishna University, Machilipatnam. Fourth, Dr. T.N.V.K.V. Prasad, ERF, Australia, Principal Scientist, Nanotechnology, Regional Agriculture Research Station, Acharya Nagarjuna, Acharya N.G. Ranga, Agriculture University, Tirupati, for sharing their expertise and insights with us. Your passion for physics and your ability to simplify complex concepts have enlightened and inspired us all. Your has undoubtedly deepened our understanding of various topics on nanotechnology. We are grateful for the knowledge you have imparted. We also extended our appreciation to all the participants who joined us today. Your active engagement through questions and discussions has enriched the learning experience for everyone involved. Your curiosity and enthusiasm are what make events like these so rewarding. A special thanks to our organizing team, Dr. M. Srinivas Reddy, Dr. N. Manjula Bharati, Dr. P. Indira, Dr. K. Pratap, Srimati P. Kusuma Kumari, IQAC Coordinator, Srimati U. Sarala, M. Hema, P. Yamini Ammaji, and special thanks to JKCFTM, Sri J.M. Suresh Kumar, Technical Assistant, for their meticulous planning and seamless execution through live online Google Meet and YouTube. Your hard work behind the scenes ensured that everyone, from promoting the event to managing the technical aspects. Last but not least, thank you to all the attendees for taking the time to be part of this webinar. Your presence and participation are invaluable, and we hope that you found today's session both informative and enjoyable. As we conclude this webinar, let us carry forward the knowledge and inspiration we have gained today and continue to explore the wonders of physics and chemistry. Thank you once again to everyone involved. Thank you.
Madam. Yes, sir. Yes. Yes. Okay, thank you. Thank you all. Okay,